Good evening. Am I audible?
Yes, sir. You're audible, sir.
Great, Navjot ma'am. Thank you. The resource person is joining in a moment. So we will start the session very soon. Ladies and gentlemen, Palvinder sir is here. We welcome you, Palvinder sir, once again. So you might have seen me working from home, but now today I'm in my office. So it's a different feeling. So I just we'll start before that. It is a customary. We have Dr. Manjot here. Dr. Manjot, I think she's there. We can see you, Manjot.
Good afternoon, sir. Sir, am I audible?
Audible.
Yeah, you're audible.
You're
Okay.
audible.
Audible. Right. So Manjot ji will, Dr. Manjot will brief yesterday's session, the first session. So the platform is yours now.
Sir, I'm briefing out yesterday's first session. Sanjit Singla, Solution Advisor of SAS, conducted second day session on advanced MI programming, delivering in-depth exploration of advanced MI concepts. The session covered non-blocking communication and AMPI synchronization, highlighting how asynchronization messaging enhances parallel efficiency. He then discussed managing large data with MPI, focusing on key operations such as scatter, gather, and all, which optimize data distribution and collection across processes. The session also included an hands-on exercise where participants applied these advanced MPI techniques to real-world application. It was highly interactive and informative session, equipping attendees with practical skills to leverage MPI for high-performance computing. Thank you, sir.
Thank you, ma'am. Actually, it is very difficult to summarize the session because after this session, there was one more session and still you remembered and you attended. It shows that you guys are attending very well. Now, Parvinder sir, with your permission, I would like to request my colleagues to share their webcams so that we can have a photograph. Today is the last day. Today, we will be completing our this 6 days program and we want to have a memory. सब लोग फोटो खिंचाते हैं यार एक दूसरे के साथ है ना, everyone for memory. So why not share our webcams for a while and switch off our except me, switch off your audio, means switch off your mics. So please share your webcams. Yes, Jitendra ji is a very beautiful place. Where are you, sir? The place looks very beautiful. This or it's a background. It is your place is very beautiful. You see us. We are in our offices. Dr. Mohit has left another session. He is conducting one more session. He has left to join this session. Mohit ji, welcome. So there are Nikhil sir. Is there Manoj Kishore, Nikhil ji, Ranjani, Sunita ji, please share our webcams. We want to see you as well as the backgrounds, you know. See, people are from different places, beautiful places are joining. There are some no winter places also, as I discussed. So, Vaishnavi, Rajreet, please share your webcam. इतना तो बच्चों को भी नहीं बोलना पड़ता. They share it first. Dr. Chidambaram. There are many others. So I wish thank you very much, ladies and gentlemen. Now I hand it over to Palvinder sir directly.
Got it. Thank you so much, Ajay sir, for again this great opportunity. Again, connecting from a remote location other than India. And so in this session, we're gonna have some hands-on experience. We'll be talking about couple of tools, my topic, all details I'll be discussing. Just confirm me if I am audible, everyone. Yes. If my audio is okay.
Yes, sir, audible.
Thank you so much. Thank you so much for the confirmation. Yes. I hope my screen is visible, right?
Yes, it is.
Great. So in today's session, we are going to talk about the GPUs, the CPU systems, how GPU is helping to our systems to process the things faster, how it is working, and how it could be useful in our technologies. So now, very first, if in the daily routine we are talking about, once again, just let me hide this innovation. Yes, now it's better. Now, so now, very first thing, the common thing we are using in every day, it's also called as the brain of a computer, that is of a CPU. whatever the part we are doing, whatever the tools we are using, the software we are using, that all is getting executed with the help of a CPU. It's also called as a brain, like who controls everything, who giving an instruction. If I want to play some song, we gives an instruction and the audio will start coming from the speakers and the song will be getting played. In case I want to download something, again, I'm sending some instruction and it's working accordingly. Now, the thing is that how beautiful it is working, how perfect it is working. Now we need to do the add-on features. As we are moving towards the more technical part, we are having some IoT things are the Internet of Things are there, artificial intelligence are there, machine learning programs are there, or some heavy things we need to execute in our system. The problem, the challenge which we was facing with this brain of our computer. Now, to control all the elements, all the hardware part, like of our systems, we are having one side, we are having a CPU, another side, we are having a humans, right? So if all the hardware components, if I gonna talk about, so we having speakers, we having a some keyboards are there, mouse is there, camera is there. Even if I talk about the mobile phones, touch screens are there, biometrics we are having. To access all the hardwares, we need an operating system. So many companies comes in the race of generating operating system. Linux is there on the one side, Microsoft is on the another side. Microsoft said like कि हम कोड नहीं देंगे अपना and we will be giving the operating system. अगर कोई Windows का लैपटॉप यूज करना चाहता है, it's a paid, so you have to pay a money अगर आप Windows का operating system want to use in your system. Another side we having a Linux operating system. अब Linux ने क्या कर दिया, वो कहते हैं ठीक है, you it's a free to use plus open source. As in the previous couple of session you had like words about the Linux operating system. Open source means Linux वाले कहते हैं कि भाई आप हमारा कोड लीजिए. In case you are a good developer, you know about the programming skills, you want to do some alteration in the operating system, आप हमारा कोड लीजिए and उसमें कुछ चेंजेस कर लीजिए, right? It's a very big myth, right? कि nowadays people used to say कि लिनक्स चलाना है तो हमें कमांड्स आनी चाहिए, या अगर we want to use a Linux operating system, उसके बिना nobody can use a Linux operating system. ऐसा बिल्कुल भी नहीं है. Because now the hardware components we want to access with the help of our operating system, जो Linux की मैं बात कर रहा हूँ, commands was necessity, it was necessary, it was we need to learn the commands, but it was in 1990s. Now every person who is connecting in this session, I hope we having a crowd of 46 plus people are there, so approximately every audience like sitting up over here is an expert in Linux OS nowadays. The reason behind the day it becomes an open source Linux, many companies comes forward. In the initial phase, we have to use the Linux operating system, like command line only. The CLI interface was there, no GUI, but many companies like grab the code of Linux and then they do some changes. And after doing some changes, now Linux is getting converted to the GUI interface. A very easy example, like why I'm saying you, everybody connecting over here is a very expertise, having a very expertise in Linux. You can even check it out, Android operating system on the Google. The Android operating system is the modified version of Linux. We never run any command on the Android operating system. If you have to make a call, you simply open your keypad and like put a number and start dialing. You never have to open the terminal or some other commands to make a call. You never have to do any command line to send a message to anyone. So what Android is, it's just a modified versions. Now, as these operating systems comes into the picture, like people are using Windows, people are using Mac, Linux, and other Ubuntu and all other versions, as they comes into the picture, the problem happens. It was in terms of operating system, it works perfectly fine, no issue at all. But the problem happens in terms of their speed. If we have to execute, if we have to run some operating some software, if we have to execute some operations, this is CPU act as a, I should say, a army. What army is like? CPU is having a course, right? CPU is having some course, and that course, I should say, it's like a worker or employees. And if we are giving some instruction, the guys are standing in a queue, and one by one, the process is getting executed. So now, what happens? We want that instead of one person working and then another is coming afterwards and another, it's like series. Instead of that, we must be having that all the team members, all the workers, all the cores should be working parallelly. It's also called as parallel computing. कि उससे होगा क्या, we would be able to complete the task faster as compared to the CPU. CPU तो हमें चाहिए ही चाहिए to do the operation. अब CPU को क्या कर दिया हमने? Along with the CPU, we had a things called as GPU. I hope you all might have heard of the GPU. Yes or no in the chat box, please. किसी ने सुना होगा कि like I want to use some video editing tools, हमें YouTube के लिए कुछ edit करना है तो ये कहीं सुना होगा कि हमें कौन सा GPU अच्छा चाहिए चलेगा. Some people might have used कि we want to do some animations, we need to do rendering using an AutoCAD or some VFX and all. So उसके लिए, या some people might have used कि नहीं यार I want to use some gaming systems, right? So for that you might have heard कि GPU is getting used, या GPU बहुत अच्छा है. अब है क्या ये GPU? So GPU is what? It's a device, right? Like being provided by multiple companies. It works along with the CPU. मतलब अब उसके साथ उसके वर्कर्स, उसके एम्प्लॉयज, आई शुड से CPU के साथ हमने GPU को अटैच कर दिया, एंड नाउ इट्स वर्किंग फास्टर. कि जो काम हम, the work which we was doing in 1 hour or 2 hours, like in terms of if I talk about some real example, the people who used to do the rendering, right, could be a video, YouTube video rendering. You might have seen the YouTuber as saying मेरी video render पे लगी हुई है. Render means they just are getting the final output after doing the editings, कि उसकी quality खराब ना हो. So what happens if it is a file of like a videos of a 20 GB, or if sometimes nowadays it's a trend of people before building, like before going for any buildings, before going for any house construction, they used to get a 3D models कि हमारा room कैसा दिखेगा, how my kitchen would looks like, how the building architecture looks like. Even they used to have a 3D view. It's also called as like bird eye views are there. तो वो images, वो data generate, the even in terms of an animation industry, right? So you can see how good the animations are getting generated. इतने अच्छे हैं even in terms of a gamings, right? इतने अच्छे graphics हैं, like you never feel कि भाई ये person, just go back and just think about the games which like we used to play in 1990s, or nearby 2005. We was having a games like some Contra, some Mario, and some that type song. Even the some, I still remember during my school days the popular game was like a road rash. एक बाइक पे जा रहा होता था person बस. And if today we will be using that games, you will feel यार ये कैसी games थी. उस टाइम पे वो it was a best, but now we are focusing more on the quality part. So GPU क्या करता है? GPU उसी प्रोसेस को जो हम CPU से कर रहे हैं उसको at same time it executed with the help of multiple cores, like उसको execute एक ही टाइम पे वो parallelly execute करता है. पहले क्या था, वो एक ही करके उसको execute करवा रहे थे हम उनके task को, whatever the task it is there. Rendering is there, animation is there, games is there, video quality is there, even in terms of a cryptocurrency. You might have heard of there's a very popular word, Bitcoin mining. Anyone? I hope I need to check the chats, I guess. Yes, because it's a trendy word is there. Bitcoin miners are there. Bitcoin mining is there. right? How Bitcoin mining is working. It's working on some algorithms. We need to run that, and depending upon that mining, we would be getting a 0.000001 of Bitcoin would be getting at it. And if we start doing with the help of a CPU, so we will be getting, I guess, like 0.000001 Bitcoin. What's the value for the Bitcoin? If I talk about in terms of INR, imagine like if we will be able to generate the Bitcoins by our own, I'll tell you like how much time it will gonna take. If I'm gonna show you the price for today's Bitcoin, just a second. Is my screen visible or it's only the PPT is visible? I changed my screen. Is my another Google, is it Google is visible? Can you please confirm? Hello?
Yeah.
Is the Google
It is
page?
visible.
No, sir, no.
No, Google page is not visible, sir.
Okay, sir, just one second. I guess I just shared the one screen that only. A couple of people are having their mics on. Please turn off the mics. Would be great. Thank you. Yes. So now here we can see the price BTC to INR. You can see the price. Okay, I guess I'm getting, yeah, it's 1 Bitcoin. 1 Bitcoin is costing me how much? 88 lakh million just for the 1 Bitcoin. And what miners are doing, what people who used to do the minings, they used to have a systems using couple of tools, and their systems would be working day and night. And if they will be working on the CPU, they never would be even in a 10 in next 10 to 15 years, they would be getting like not even a 0.5 Bitcoin, right? So now what the people used to do to perform the task better, to perform the execution faster, we are taking an help for the GPU. GPU is like graphical processing unit. Now, who introduced this CUDA? CUDA is one of the concept which was introduced by NVIDIA. So NVIDIA comes with the great concept ki bhai, in case you want to increase the things, how GPU looks like. I hope I was having a picture. If not, I'll show you on the Google. I guess it's not in the slides here. Yeah, I'll show you that. So again, NVIDIA comes with the CUDA technologies. CUDA did what? Like कि एक ही task को हम multiple parts में divide करके execute करेंगे, just to increase the like speed, just to increase the computing, just to increase the solving of algorithms. This one. And how it works actually. Today what we will do using this CUDA technology, I will be showing you how fast it's working. Right, so in case if in the demo we will be taking help of a Kali Linux. In Kali Linux we will be having some hashes. It would be a MD5 hashes, or it could be some WEP, WPA or WPA2. There are like more than 1,000 hashes we can crack using this hashcat. And I'll show you how fast it would be working. How like easily it would be able to crack your things, I mean, whatever the task we are giving. In our case, we will go for the hash cracking. In case we are having a hash, how fast it would be working. Right. So now one quick video I would like to show you before going further, just giving a little idea how parallel things are working here instead of CPU in comparison to the CPU and the GPU. Please have a look. Please confirm if this video is audible to you.
Sir, it is not.
audible.
Yeah,
audible.
not. It is not audible.
Okay, it's not audible.
No, sir, it is not.
Just one second.
All right, I introduced to you Leonardo, and he's going to paint a picture.
Still not.
It is now. It is audible.
Okay, thank you for the confirmation. Just a second.
All right, I introduced to you Leonardo, and he's going to paint a picture for you guys in the way that a CPU might do it, as a series of discrete actions performed sequentially, one after the other. In 3, 2, 1.
So you can, sorry, its video is getting skipped. So you can see how CPU is working.
All right, I introduced to you.
I'm facing some issue in the video part. Just a second, guys. One second, I'm resharing it again.
Hello. Hello.
Yes, sir. Am I audible?
Yeah, you are, sir.
Yeah, I'm just resharing the screen again.
Hello.
Mani, sir, yes.
Yes, hi. Am I audible?
Yes, yes.
Okay.
All right, I introduced to you Leonardo, and he's going to paint a picture for you guys in the way that a CPU might do it, as a series of discrete actions performed sequentially, one after the other. In 3, 2, 1. Let me.
Quick example, like how the series are working in terms of a CPU. It's executing instruction one by one, right? In this case, the guy is using some painting example. Could be anyone, right? Just for the explanation they are using here.
All right, I introduced to you Leonardo, and he's going to paint a picture for you guys in the way that a CPU might do it, as a series of discrete actions performed sequentially, one after the other. In 3, 2, 1. Let me speed it up. Ladies and gentlemen,
Leonardo 2.0.
when we hit this trigger on this thing, 2,100 gallons of air goes through these accumulators, out these valves, into all 1,100 of these tubes, into these tubes in which the bottom of is a paintball. Each of those paintballs will fly across 7 feet of space and in 80 milliseconds reach its target, hopefully. When it's all said and done, it's going to paint
You
the Mona
can see
Lisa.
how the parallel
CPU
it's working
painting
with the GPU.
demonstration
Yep.
in 10,
9,
9,
8,
7, 6, 5, 4, 3, 2, 1.
gentlemen, science class is now over. Thank you.
Yes. Instead of a series, if it is working parallelly and how fast it is. Right? Now, the key difference is in terms of a CPU and the GPUs are there. It's handle the main functions. Main functions means if you are installing an operating system, like it would be executed by the CPU here. If you are using some software, executing some softwares, like running them, so it would be installing session will be getting done with the help of CPU only. If it is some special task need to, and some games are getting played, some renderings are happening, then it goes to the GPU. First, it comes to the CPU, execute, then it goes to the GPU part if it's required. Right? It's CPU as we seen in the video also. It's a processing is what? Serial, like one by one, step by step in the queue. And in terms of GPU, here we having a parallel, that instructions are going parallelly. Another here we having the designs are there. In terms of a design, here we having a cores are there in both the cases, but a fewer. But in case of a GPU, we having a higher number of cores are there. So applications, we simply use a general applications. We are using it here, a normal operating system and executing a little simple tools. And we having an advanced or complex, if we want to use, then we need to go for the GPU processor. Well, so now what we will be doing, I'll be showing you the demo. The threads. Threads are what here? In terms of like cracking part, like if I show you threads are what, like how many, if you see the number of cores while the pictures was getting painted, like it would be having 100,000 something is there, right? So that 100,000 points from where the paint was getting out and it was coming on some display. So that's at a course, like giving an instruction and sending it to the further. So here we having a threads. So what I will be doing now, we will be performing one practical. In the practical, we will be generating some hashes. Could be MD5 or this, as you can see, SHA-1, we can have it a WEP, WPA, PHP, MD5s are there, could be. So first of all, we'll be generating that hashes, then we'll see how fast it's working, how much time it will be taking to crack it. And even if you are using a password, imagine if you are using a password, how long it will be taking, right? So before showing the practical, let's test. Can you guys give me some examples in the chat box? How complex the password would be? You can mention any testing passwords, and I will show you how fast we can crack the password. Can I have a 5 to 6, like a couple of inputs from your side in the chat box? You can mention any complex passwords, and I'll show you how much time it will take to crack such passwords. Let's see if I'm getting some inputs in the chat box. You guys can mention any complex passwords. No worry. Yes, anyone? Till now, no inputs. Okay, we got one message. So here you can see we got one input. Let's see how please don't mention your actual passwords. Otherwise, people like Palvinder would also be ready with the paper and pen. वो आज लिख के शाम तक आपका account login हो गया. So don't mention your actual password. You can mention some testing. Okay, so now let's go for this, Ramya. I hope my screen is visible. You guys even check. So here I'm going for. Here it is. Yes. So now if I would be having a password like only Ramya, RAMYA. Can you see how much time it will take to break your password or crack your password? 200 microseconds. Okay, let me make it little complex. So Ramya is having at the rate. So one by one, I'll be keep increasing the complexity. So here I'm using R at the rate MYA. Here it is. It will take 33 milliseconds. Wow. Let me make it put a star in the last. So here I'm just having the asterisk sign. 2 seconds. Wow. You can see. And let me have some numeric copy as it is the Ramya's password. I copy paste the same. Can you see how complex it is? If I want to crack this password, I need crack doesn't mean ki in case I want to hack into the Ramya's account and it will take me 5 years. Crack means actually if I would be having some encrypted value or the hash value of this Ramya asterisk star 1992 and how like much time it will be taking. Right? So how much time it will be taking if we having a hash. But now the problem is that don't think that it doesn't mean that Ramya is very safe. Like wow, Ramya is saying wow sir, like I'll not be getting hacked. So nobody can hack me. There are some cases even with the complex passwords, with the complex things, the people are getting compromised with the help of a social engineering. Right? Yes. But like how it's getting, you might have seen the cases are getting high in terms of every day I used to get some messages or some calls from like people that sir मेरा इंस्टा का अकाउंट हैक हो गया, मैंने न्यूमेरिक वैल्यू भी उसमें रखी थी, मैंने स्पेशल कैरेक्टर भी रखा था, it was having an upper case lower case also and still my password got compromised, मेरा इंस्टा हैक हो गया. एंड वी यूज टू से आप सब बोलते हैं कि पासवर्ड कॉम्प्लेक्स रखो, वो ब्रेक नहीं इजीली होता, इट टेक्स 5 years. बट नाउ द प्रॉब्लम इज दैट कॉम्प्लेक्स रखने का मतलब है उसका जब वेबसाइट में जाके सेव हो जाएगा उसका हैश वुड टेक अ टाइम टू ब्रेक इट. बट अगर हमने प्लेन टेक्स्ट ही पासवर्ड किसी को दे दिया, if I would be giving my password to someone ki like in terms of a phishing attacks, like nowadays scammers are doing what they are sending you they're having so many techniques. If one example I'm gonna share you, scammers are doing what, they're gonna text you on your Instagram that hi with your name, hi Palvinder, we gone through your profile, or sometimes they pretend as an Instagram logo they will be using that, and we thought like, oh, we got a message from the Instagram, and they would be having a names like Instagram security team, Instagram verification team, Instagram or a Snapchat or something, some XYZ admin team. The blue tick verification is there, so your account is eligible for the blue tick, please enter your details. So that is called as a social engineering. And what usually we do, it happens with couple of some Bollywood and Hollywood the celebrities also, in which they get a mail and they fill a form. Oh, we are getting verified, we are getting a blue tick, my account is getting validated, so let's fill a form. Right? There was one very popular case, like I'll not go for towards the case side because it's again the another story is there. That case is called as it was fappening, F, right? F for France, fappening. Fappening happens in the US, not in US, like across Europe also. Couple of celebrities was there, some male and female celebrities was there. So what they guys get in 2017, not 27, I guess 2016, they got a mail in their mobile phones and their laptops. The mail was, the guys was pretending they are from Apple. Now what happens, they get a mail that you have to verify your account if you want to continue, otherwise your Apple account or your iCloud account will be getting banned or blocked. So maximum of them what? Oh, let's go for a verification. It's annual verification, some XYZ verification. It was mentioned. As they click on it, a very genuine looking page appears. मतलब एक बड़ा अच्छा सा पेज उनके सेलिब्रिटीज के सामने आया. उनको लग रहा था शायद हम एप्पल की वेरिफिकेशन ही कर रहे हैं कि हमारे अकाउंट को वेरीफाई करना जरूरी होगा. But what happens as they click on the link, a genuine page appears, right? It looks like a peer. I should not say it's a genuine page. It looks like a genuine page. Now, what they did, they fill their email IDs, they fill their passwords. It was a part of, it was asking, right? It fill a password, they fill their date of birth, they fill some XYZ questions was there. And uske baad kya hua? The scammers who created that scam, who launches that campaign, jisne wo sara banaya tha, he grabs people's username, people's email IDs and the password. अब होता क्या है, like how bad it is, what was the bad thing happens कि जब हमारे आईफोन्स हम यूज कर रहे हैं, हम एंड्रॉयड फोन्स यूज कर रहे हैं, अगर हमारी ईमेल आईडी का पासवर्ड किसी के पास गया, इफ एनीबडी ग्रैब्स माय ईमेल आईडी एंड अ पासवर्ड व्हिच आई एम यूजिंग इट फॉर द it would take, yeah, so the email ID password which I'm using in the Android phone or in the iPhone, same thing, उनके पास iPhone के iCloud के passwords आ गए. So it's a by default function in your mobile phones कि जो आपकी मोबाइल की फोटोज होती हैं, they are getting upload to your Gmail account, Google Photos. If you are using an iPhone, by default your iPhone photos are getting uploaded to the iCloud. You can even read about the case happening. उस case में क्या हुआ? The celebrities' personal pictures, maybe they were sharing with their some husbands, their boyfriends, or their girlfriends, like all was there in their account. It got leaked on internet, right? So in such cases, they highlighted this issue. Why I was on this story, they highlighted this कि sir मेरा password तो बहुत strong था. I was having uppercase, lowercase, special character, numeric values, and my password was of 20 characters. Right? So still it's important to have a password, a complex password, but make sure you should not be a part of any social engineering. Okay, now let's come to the another here. We having another account, Apple 11 or Apple 1215. Let's see at the rate. You can see. Oh wow. You can see if we having an Apple at that rate, it will take a 1 month. And this time is coming if we are using a GPU. And if we will be using a CPU, this 1 month would be 1 year. So slow is there in terms of the outputs. And here we are getting one more from Dr. Mohit Arora. Great, sir. Your password is really good. But let's see. The passwords which I got here, I will be showing in my operating system, the Kali Linux, the one which I'm going to use. I will show you, maybe these all passwords are already in my list. That is already saved. There is one worldwide list are available of people's password. Wow. Dr. Mohit sir, you can see it's almost impossible, I should say. Otherwise, from generation to generation, we need to pass on our systems कि बेटा इसको continue रखना, ये हमने 41 trillion के बाद ही password crack करना है. Right? But another side, we have to make sure, guys, please don't innovate on the screen. Please avoid doing such things on the screen. One second. Yes. Yeah, thank you. Okay, I would take a computer about, it would take a computer about 400 years to crack your password. Great, Vandana, ma'am. You are also safe. I'll show you the list of passwords, the one which I am having. Right, so make sure your password should also not be a very common password. It should not be a meaningful password, and you must never be used a same password for other account. That is a big mistake we people are doing nowadays. जो हमारा Gmail का पासवर्ड है वही Facebook का पासवर्ड है, That same password we are using it on Twitter, same password we are using it on some Instagram. It happens with Mark Zuckerberg. His LinkedIn password got leaked क्योंकि LinkedIn 2016 में कॉम्प्रोमाइज हो गई थी, उनका सारे पासवर्ड गोज पब्लिकली, एंड उस लिस्ट में मार्क जुकरबर्ग का भी पासवर्ड था, राइट? बट लिंक्डइन ऑल्सो मेल टू एवरी ऑफ देयर कस्टमर कि प्लीज अपने पासवर्ड चेंज कर लो भाई, कि आपके पासवर्ड गॉट लीक्ड एंड कोई हैकर आपका लिंक्डइन लॉगिन ना कर ले, तो मेक श्योर टू चेंज योर पासवर्ड्स ऑल्सो. अब हुआ क्या, एवरीबडी लाइक हु गॉट सम मेल दे चेंज देयर पासवर्ड इंक्लूडिंग मार्क जुकरबर्ग. बट हैकर्स ने क्या करा, व्हाट हैकर्स डिड, दे सिंपली यूज द लिंक्डइन पासवर्ड जो पब्लिकली था. दे ट्राइड लॉग इन लिंक्डइन बट मार्क जुकरबर्ग ने ऑलरेडी चेंज कर लिया था, right? But what hackers did, they simply use a password of LinkedIn and they try login the Twitter and वो हो गया. मतलब that mistake was being done by Mark Zuckerberg also, कि हम being a human हम same password रखते हैं because it's very difficult. Can you please guess how complex the password would be of Mark Zuckerberg? कितना complex होगा? How complex it would be? Any quick idea? मतलब कितने होगा, 100 कैरेक्टर्स का या 20 कैरेक्टर्स का? अपर केस, लोअर केस? Ajay sir, can you please confirm me if I'm audible perfect? Or is there any delay in my audio getting?
Audible, sir.
Audible, sir.
Yeah. You want to see the password of Mark Zuckerberg? Yes or no in the chat box? How complex he was having? Should I show you the Mark Zuckerberg's LinkedIn password? Like what he was having a password, उसका LinkedIn का password था क्या? क्योंकि वो publicly आ गई थी that list and anyone can come and see the password, कि उस list में भी हम देख सकते थे. Even I'm having hundreds of जो lists हैं, इतनी data breaches हो रही हैं कि lists are publicly. Here you can see. Sorry. Mark Zuckerberg LinkedIn password. Sorry. Bicycles. Wow. Can you see on my screen? What's the password for Mark Zuckerberg? So that's the big mistake he even did. The password was DADADA. Da 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 da. This was the password. And the same password got logged in. Da da da. Right? So this same password was on like other social media accounts. So it's got LinkedIn login here. So always keep a different password for the different. Okay, let's come to the practical part now. Here I'm turning on my Kali Linux. Let's do some password cracking. For the time being, it's getting turned on. Let's generate some hashes, which we will be cracking. Okay, let's get it power on. It's almost on. Okay, so this is my Kali Linux. So what Kali Linux is there? Kali Linux is an operating system, again, a version of a Linux. In this case, what we are having, the maximum, I should say, a cybersecurity tools, password cracking tools, like it's a heavy tools like which needs a GPU processors to fasten the process. Here you can see the tools which are available, even for forensics, even for the exploitations, report generation, Wi-Fi attacks, like normally we have Wi-Fi hacking. So that's a wireless pen testing is there, that all. So we will be using a tool called as a password attacks, and here we will be using a tool called as a hashcat. First of all, we will generate couple of hashes, then hashcats इसको हम reverse करेंगे. And now for reversing, we need a word list also. चलो, before going for that, मैं पहले कुछ hashes generate करता हूँ. Let's go for it. So here I'm taking a help for one of the website. Let's go for my Reckle salad. Yes. Let's generate some MD5 hashes. So I'll pick couple of names from the participants. Big thanks for everyone who is joining this session. For giving the time and learning some new things. Not 100%, but at least even if you are grabbing a 50%, still it's a worthy, because the new things or new parts are important. Okay, now. It's loading, wait. The place where I'm sitting is so cold. Even with such jackets, I'm feeling cold. Okay, okay, it's working now. Let's have some name. Here we having Dr. Manjot Kaur ma'am is there, so I'll pick a name Manjot. Ritu Agarwal is there. I'll pick a name RITU. So a couple of more names I'll be looking for. Here we having Dr. Pooja Singh. I'll pick a name POOJA. So here on the another side, what we are getting, you can see here. Okay, now it's working. Okay, Manjot ma'am is there. Ritu ma'am is there. Pooja ma'am is there. Dhruv is there. Here it is. On the other side here, you can see here I am getting the hashes. The hash for this word Manjot, here we are getting this one. So what we will do, these hashes which we are generating, it's a MD5, right? And I'll tell you also like how we can identify that MD5 is there, or MD like 256 SHA-1 is there. This one. So one or two names I'm just want to pick up. Any random names here. Sorry. So I'm picking couple of names. It's like let's make it little complex. Test at the rate 123. Morning. I'm making a capital also. Good morning. Yes. Let's have some complex word also. I'm having it like yeah. So here I'm having one complex hash like this also. So what I'm going to do, I'm going to copy these hashes. Copy. I'm saving it in one of my notepad. Yes, these are the hashes which we generated. So I'm giving a name to this file. The task hashes, saving it on desktop. I hope no other file is there with the name of hashes. So the file name is hashes. I click on save hashes.txt. Hashes.txt. Saving. Now, what I will be doing with the help of threads and GPUs, I will be cracking these hashes, right? So now the hashes which I generated, and what I will be doing, I will be using one word list, and the software which we are going to use, the software name is Hashcat, right? And the word list that we will be using, it's called as RockU. So now opening a terminal, here it is. So let me show you the word list, the one which I'm having, in which we having hundreds of passwords. So let me show you the word list. Catch word list. Here you can see millions of passwords are there. I hope this is not how we can see. Let's filter some name here, right? Let's filter some name. I want to find in this word list any particular password you want to find. You can text me in the chat box कि वो देखते हैं वो पासवर्ड हमारी वर्ड लिस्ट में सेव है या नहीं है. वर्ड लिस्ट क्या होती है जिसमें लिस्ट दुनिया भर के जो पासवर्ड्स हैं, जो यूजर नेम्स हैं, व्हाट पीपल आर यूजिंग, that we can check. So here we can check. Let's see one password we're getting honey, HONEY. So for that we'll use a command grep HONEY. All the words like all the password which contains a word honey, even the like character this word honey, let's see we'll be able to find it or not. I hit enter. You can see here all the password which contains a word honey. Here you can see. And we'll be using this word list to reverse our hashes. Here it is, honey. So we're having a simple like just honey also. Even like it's not like only this one. Let me clear this. Any other password guys you want to find, please? You can text me. Any other password you want to find, if it is there in the list or not? No? Okay, let's go for some complex password. Yes, we have in our word list. It's there. Let's see. Create password underscore 123. No, this password is not there in our word list. Create password underscore like 123. Good password. Okay, now let's go for the hashcat. So here, let's see how long it gonna takes to crack a password. I'm using a hashcat using -m. M is used to inform the hashcat कि जो हम hashes crack करने वाले हैं. So what is the type of hashcat? Hashes, is it MD5 or MD4 or SHA-1 or WPA or XYZ, right? So here we are having a list proper. You can see how many hashes it's supporting. So the one which we are cracking, here is the list, hash modes. The one which we are cracking, we are using a MD5. The properties for the MD5 is like it would be of 32 characters and containing alpha numeric values, or I should say hexadecimal values 0 to 9 and A to F. So in our case, the hashes, it's 0, 0 means MD5. So I'm using hashcat -m, that is 0, that the hashes are MD5. Attack type is a simple, like I just want to use the word list. And then I'm having the hashes file. My hashes file is on my desktop with the name of hashes.txt. Space the word list file, which I'm going to use here to break these hashes. Let's see how many hashes goes break. And so now the word list file, the one which I'm using, it's called as a rocku user share word list rocku. And here I'm mentioning the threads. The threads means how many parallel tasks I want to use here. So if I'm giving a number here 90, let's see, we'll be getting an error. Enter thread -1 is thread unrecognized singles ones. One second. Here you can see. Can you see an error here? Here you can see. In my case, we are doing here, it's giving me an error that not a native Intel Opal runtime is there. What happens? I'm using this Kali Linux in my VM here, not in my actual system. The graphic card which is there in my system, it's not supported to the VM here. Either I need to take the Kali Linux to the main system, right? Or I need to have an extra separate GPU which should be getting connected to this my VM here. Now what I have to do here, they are saying कि ठीक है अगर आपके पास नहीं है, you can use a command to override this, कि इसके बिना ही आप इसको process करवा दो. But still it's let's see how much time it's showing. So here what I'm doing here, minus t is like mentioning here. So here I'm mentioning --- force. Now let's see how much time it gonna take. I hit enter. So here we are getting interrupt monitoring internet online system. Just a second. Details and passwords. We're getting some error. Hashes. 1 unique salt. 7 digest. -A0. Desktop 0. Let me check. We are getting some hardware monitoring internet not online system. Temperature about. The temperature is not so high. We're getting an error about the temperature. 1 second. -MA, this. It's already sudo force weighted. Maybe some error is there, some issue is there. Here you can see when I simply decrease the number of hashes, maybe it's taking a lot of load, which my system is unable to handle. And I was getting an error of the temperature. So what I did in this case, I simply mention only one hash कि मुझे भाई 6-7 crack नहीं करने. I just want to crack the only one is there. And how much time it took, imagine here. As I started, let me show you the time difference here. I hope it is visible in the last. What is the started time and what is the stop time here? Here it is. And if I would be having a higher number of targets, the hashes, it's like putting a load on the system and it's getting a little heat up. And that's why it's giving me. Let me try to increase the number of hashes to 2 or 3. Just a second. Instead of 1, so I'll have another file. Copy. Let's see if we can increase to at least 3 to 4 hashes. Rename hash 2. The first one we did. So instead of first one, what I will do, because last one was complex, so I will be keeping last 3. Let's see how much we will be able to do that. So I'm saving this file with last 3 complex hashes because other was a normal name. It's a hash 2 is there. So again, using the same command, let's see, I'm clearing the screen. So I'm just changing in this entire command. I'm just changing the hash file. Hash 2. Let's see. It's working. Great. So wow, very first thing we are able to crack a password. Can you see the one password which we are able to crack? Out of 3, we able to recover 1 only. Wow, the other 2s are safe. And the one which we are able to recover, let's see what password it is. We can check the port file, but here it's directly getting displayed. Can you see which password we are able to grab? The most complex password we are able to grab. It's getting decrypted. Even this process, like in this case, the word list which I'm using, that it contains this much passwords. You can count how much it is. It's approximately, I guess it's a 14 million. I guess so. It's a 14 million passwords are there in the word list. And so out of this 14 million and how fast it is working here, you can see. Right? And if I would be having some more higher files are there. Word lists are what, like a list of passwords. Any task we can allocate to the system, like for cracking and all. But in my case, I given share this demo with the help of this hash cracking, right? So this is a quick demo part. And 1 second, let's come back to the process. So in this case, how's happening? It's happening 14 million passwords, which we was trying here. It was getting billions of hashes per second. How it is working? It's not possible like directly testing the 14 million passwords in just quick seconds. And here you can see, and it happens with the help of this CUDA. Just a second, let me have some this one. Yeah. Right. So again, why we are focusing a GPU? Obviously, it's a speed is high. We are basically using for the brute force attack or the dictionary attacks, right? And here are the couple of like the GPUs which we can use this. So here we have given one example also. Again, the tool which are popular for the CUDA cracking, that is for the hashes. Couple of are there. Just it's not only the 3. It could be 300. So the one which are the most powerful and the most popular are there. It's a Hashcat and the JTR John the Ripper, and this OCL is there. It's an older version, but it's the new one is already there in the Hashcat. Right. So this is a demo which we perform it using the Hashcat. We generated the MD5 with the help of either we can do using some tool or we can use some third-party websites. So in our case, we use a third-party website, right? Yeah. Here the commands are there. I'll give you these commands in case you want to access. It's called as a mask attacks are there. If you are providing some dictionary, it's called as a dictionary attacks are there. To stop and restore, we can have it this command restore. मास्क अटैक मीन्स कि हमें ये पता है कि जो पासवर्ड है, जो हैशेज हैं, उसमें क्या क्या हो सकता है. हम मुझे ये सेकंड कैरेक्टर नहीं पता, मुझे ये फोर्थ कैरेक्टर नहीं पता, बाकी के मुझे पता है. So this is how it would be cracking. Sorry, this first is question mark, second is a, third is question mark. This 3 means we want to do the mask attack. -A, 3 is like a mask attack. So what was the meaning of 0 here? 0 means ये जो hash है, that hash means it's MD5. That's a 0, 1. Right. So good use and the bad use for the CUDA cracking. It's basically used for checking the password strengths are there. For data recoveries, we can use in case our data goes lost. It helps a lot during the days of ransomware attack. So when we have to work on some data recoveries part there, not 100%, but at least couple of files, couple of directories we was able to grab using this, right? For research and development. The bad use people are using in the ransomware parts are there, data breaches are there. That's the bad use of it, right? So again, GPU and CPU, right? The big difference, like the big conclusion, CPU is a brain. GPU उसको help कर रहा है to enhance the process parallelly, right? So this is a quick overview of the CUDA cracking, CPU's part, GPU parts, threads parts. So in case you're having which doubts and queries, not taking much time, I guess we are almost ending up with the times also. And would be great if I can have a couple of queries and doubts for the same.
Sir, Vandana Sharma says the session was very interesting.
So can you please repeat?
Vandana Sharma.
1 second, sir.
Vandana Sharma says that the session was very interesting. Can you hear me, sir? Is it audible?
Yes, sir, it's audible. Sir, Hanji, sir, can you please repeat?
Vandana ma'am says that the session was very interesting.
Acha. Thank you so much, ma'am.
Princey Tyagi says fantastic and very informative session.
Thank you so much, Princey Tyagi. It's my honor. We are glad to share such things because as we are like working around the industries, the things, the experience, the knowledge, the case studies, what we are getting. So it's our job, I should say. It's our responsibility, I should say. We should sharing because we all are a team actually in IT, information technology, or computer science, or now cyber thing. These things are not even limited to the IT or a computer science. Either you're coming from any domain, these all things are compulsory day by day.
Excuse
Right. So it's our definitely a responsibility to share this part with you.
Somebody wants to say, please
Yeah,
carry
excuse
on.
me, sir. Navjot this side. Parvinder sir, I had a little concern in mind. Like, as let's suppose I am working with Red Hat, Kali maybe. So
In
by
Kali Linux,
default,
yes.
yes, maybe. So by default, I have the entire access, and suppose I have an access to the shadow file. So
Mm-hmm.
whenever we check the passwords, by default, the passwords they are encrypted.
Correct.
I believe that is MD5 kind of. Sir,
No,
that
that's not an MD5. It's a different is there.
my concern is that if I am admin,
If you are
having
admin,
the
correct?
entire right to interact, to create users and handle the permissions and all. So why exactly the passwords that we are creating is by default shown as encrypted?
No, no, no. Imagine in case like your system goes into the hands of some unauthorized person. Sometimes we used to share a system with the family members with an over some office people are there. So that company don't know. Otherwise, they need to create a different formulas for the different type of audience. So in general, they keep it कि अगर आपका system कोई access भी करे other than you, right?
Okay.
So it
I
should
thought there is some other reason, like from security policies or some, like in the other side कि शायद कुछ और reason
नहीं,
रहा.
it's obviously अगर वो plain text में उसमें रख देंगे, they need to keep it because every time you are logging into your system, वो backend से कहीं से validate तो करेगा ही.
हाँ
तो
जी.
अगर उसको plain text में रख देंगे, so that problem would be, तो वो plain text like
Accessible हो जाए.
कोई भी उसको check कर सकते, कोई भी visible है. And imagine it's not even you are sharing your system with someone. Imagine your system would be getting some exploit. ये
Correct.
हुआ था 2017 में एक ऐसा एक्सप्लॉइट आया. इट्स कॉल्ड एज अ वॉल्ट 7. वॉल्ट 7 वाज WannaCry. वो एक ऐसा एक्सप्लॉइट था इन विंड लाइक यू टोल्ड मी लाइक इन लिनक्स जैसे आप एग्जांपल दे रहे हो. इट्स द पासवर्ड्स आर गेटिंग सेव इन द शैडो फाइल. विंडोज में पासवर्ड्स आर गेटिंग सेव इन द सैम फाइल.
Right, sir.
राइट
Right.
अब हुआ क्या द एक्सप्लॉइट वाज सो बैड मतलब मेरे एक्सपीरियंस है सो बैड कि
Right.
आपका सिस्टम यू आर सिटिंग एट योर होम यू आर यूजिंग द सिस्टम इन सम ATM machines you are using in the IoT devices without even getting any email without getting any link without getting anything your system would be getting controlled by some hacker. आपने कोई क्लिक नहीं करा आप घर पे आराम से लाइक सो रहे हो आपका सिस्टम कहीं चल रहा है सर्वर है हैकर कैन टेक अ फुल एक्सेस. अब अगर उसने फुल एक्सेस रिमोटली विद हेल्प ऑफ IP ले लिया तो अगर उसको प्लेन टेक्स्ट में रख देंगे एंड हाउ बैड इट इज कि
Like
कि वो
suppose.
आपका सारा देख लेगा.
राइट सर. सर एक छोटा सा और कंसर्न है कि लेट्स सपोज आई एम अ वैलिड इंडिविजुअल, मतलब मैं ही हूँ जो डील कर रही हूँ उससे, लेट्स सपोज. तो अगर मुझे शेडो फाइल से पासवर्ड रिट्रीव करना हो तो व्हाट इज द बेटर वे टू गेट इट एनक्रिप्टेड. मतलब मान लीजिए मुझे ही है पूरा असेस, क्योंकि वहां पे तो शेडो में तो इट विल बी ऑल एनक्रिप्टेड ओनली. तो
शैडो से
how
डंप करके ना वी कैन क्रैक इट यूजिंग द हैशकैट आल्सो वी कैन क्रैक इट
अच्छा.
यूजिंग द जॉन द रिपर आल्सो. जॉन द रिपर थोड़ा बेस्ट है वो ट्राई करके आप कर लेना.
गॉट योर पॉइंट.
देयर आर
थैंक
प्रॉपर लाइक टूल्स अवेलेबल. थोड़ा सा अगर इस पे थोड़े सर्च करोगे
जी.
एंड आपको इजीली मिल जाएगा. आप
गॉट
कर
इट.
भी सकते हो बट इफ यू आर डूइंग इट द फर्स्ट टाइम ट्राई टू कीप अ पासवर्ड इजी.
No, sir. हाँ, sir, I got your concern. Actually, sometimes we deal from students' point of view as well. तो
अच्छा
कभी
ओके.
ऐसा concern हो जाता है कि kids are very curious to know कि ये तो मेरे को अपना पासवर्ड तो दिख नहीं
नहीं
रहा.
जी इन केस यू विल बी एबल टू डू दैट्स ग्रेट. नहीं होगा तो यू कैन टेक्स्ट मी एंड और यू कैन टेक्स्ट अजय सर विल गेट कनेक्टेड. आई विल गिव यू सम रेफरेंस फॉर दैट. काफी
Absolutely.
कंटेंट अभी रिसेंटली 2 days बैक आई वाज हैविंग सम सेशन ऑन दिस पार्ट कि
Right.
डेस्कटॉप सिक्योरिटीज. तो उसमें आई शोन सम डेमोस ऑन इट.
Okay, thank you so much, sir. Thank you so much, sir.
थैंक यू.
Good afternoon, Plavinder sir.
गुड आफ्टरनून सर.
Sir, one question is, sir,
ਹਾਂਜੀ.
as I am working in multimedia and animation department,
यस
and we have so many kinds of GPUs having
जी
installed in our
करेक्ट.
system, sir. Sir, till the date, we just take the GPU as for the graphical enhancements. We do to solve the graphically the utilization of the graphical utilization of GPUs. Since the day I have joined this session, I just come to know about the that the processing for the additional processing being done by
करेक्ट.
the processors along with the CPU, sir. And
Correct.
recently we just bought the NVIDIA graphic card T1000. Having
3000.
DDR6 4GB VRAM and the
Okay.
CUDA cores.
Okay, with the
And
CUDA course.
we don't bother,
This.
sir. We don't bother about the CUDA cores. Today I just came to know about the CUDA cores, sir.
Actually, obviously, like it's in technology, nobody is 100%. कुछ ऐसी चीजें भी होंगी जो मुझे भी आज में टाइम पे कहीं कहीं से सीखने के लिए मिल जाएंगी. जब GPU आया था ना, everybody was thinking about like, okay, यार, in case I want a good graphics of my system,
हाँ, yes sir, yes sir.
वीडियो क्वालिटी अच्छी आने के लिए
Yes
हम वो
sir. हाँ. Only
50,000 का
since sir,
GPU
since
लगवाएंगे.
this perception is still is there, sir. Still in the
Still
minds.
is there.
The GPU are for only for the graphical enhancements, or even
Graphical
the high quality, to produce the high quality graphics, the rendering of the high quality graphics. When
Correct.
sir, just when the day I just entered this HPC session, I just came to know about the ये एक और भी काम कर सकती है. Other works can it also do.
And obviously, as your point is very valid, कि many audience are there on the planet जो आज भी इस misconception में है. तो इसीलिए we used to conduct such sessions. So big thanks to the LPU first of all
Yes,
for acting as a bridge between you people and me.
yes sir,
Right.
yes sir.
तो वो
Thank you.
कुछ चीजें हैं जो कुछ मेरे से आपने सीख ली होंगी, कुछ और भी बहुत सारे अच्छे अच्छे स्पीकर्स यहाँ पे प्रेजेंट थे.
Yes.
राइट. सो दिस इज एक्चुअली द मोटिव. सो अगर आपने कुछ गेन करा है तो a big thanks to the Ajay sir, big thanks to you also
Yes,
for
sir.
managing, because almost like being stuck in so many things. Ajay sir, नहीं पलविंदर, ये तो होगा ही होगा, ये तो हमें करना ही करना है.
करना है.
It's
Yes.
early morning here, the place where I am.
Yes. Yesterday,
So
I woke him up. Actually, I called. He was in sleep, and he said, "Sir," I said, "Okay, I disturbed you, but yes, something has to be done."
yesterday morning I got a call nearby 4 a.m. and like, obviously it's 11 or 12 a.m. in the morning at your places. So I got a call like, क्या हो गया जी sir? But still, sir, it's my glad to be a part of this. And thank you so much everyone for your kind participation. If you're having any feedbacks or anything for me, you can drop me in the chat box. I'm happy for it.
So great.
Thank you so much, Jyoti ma'am. Mani Arora, thank you so much. Vandana ma'am, thank you so much.
Thank you, sir. Thank you, sir.
Yeah.
Thanks a lot, sir. Thank you very much. And we wish we should be there in Connect in future also for many such programs. And I request you to be present in the valedictory session 6:30 to 7:30. Sorry, 7:30 to 8.
7:30 to 8. Okay,
Yeah.
I'll try, sir. I'll try my level best.
Right. We have sent a mail to you also. So
I
please.
got a mail. I got a mail.
So have a great time.
Thank you so much, sir. Thank you so much. Thank you so much, every participants, for your kind participation and giving your valuable time. Thank you so much, everyone. Thank you. Thank you so much, Sunil Rathod. Thank you so much, Manoj Pradhan. Thank you so much, Abhishek sir. Thank you so much, ma'am. Vandana ma'am.
Sir, once again.
Good afternoon. Good afternoon, Mr. Ajay. Good afternoon, everyone. Good to be back again.
Right. So today actually is the last day of this program.
Yes.
And as we all have come together, so it is the time if my friends share their webcams to have a photograph with you.
Oh, that'll be very nice. Sure.
So please share your webcams we will have a photograph with Mr. Sitaraman. Those who kindly share your webcams. So there are a lot of webcams are there. Dilip Borkar. I could see so many people. I could see so many people over here.
It's a Saturday afternoon.
Yeah.
Um,
People are in their offices.
Offices too. I could sense that. Okay.
Okay, sir. Just 2-3 minutes more people are joining.
All right.
We
Okay.
can see some. Right. Dr. Manjot, Neeraj, Dr. Borkar, Vaishnavi. Okay. Neetu Kumari and all. Okay, then I think Neha must have taken the pics. And
Okay.
we are good to go, sir. The platform is yours.
Thank you. Thank you. Thank you so much. Thank you, everyone. Again, good to see a huge audience. I sort of participated only in the last 5 minutes of the previous session. I'm sure all of you would have enjoyed. So what I am expected to do now after the first session that we've had was the first session, some of you might have attended, was largely around setting the foundations for high performance computing so that you could have gone through all this entire 4-5 days since then. Today, we'll be talking again at a large level, not getting into the minor level of detail. It's all about the futuristic trends, not just in high performance computing or quantum computing, but also in AI. So how I have structured this is I am actually someone who have worked a lot on AI, generative AI projects. I can't see that in isolation. Any advanced generative AI applications, for training huge data sets, all of that need to run on, high performance computing systems. So that's where I have got an understanding of what HPCs are all about. Quantum is probably, in terms of the knowledge that I have, is something similar to most of you. Just out of interest, I have gone ahead and read it. If anybody out there says that I'm an expert in quantum computing, hats off. It's an area which is seriously evolving. So on the areas around high performance computing trends and quantum computing, I've attempted a lot to give you a feel for it. On AI, there is a lot of very interesting stuff I've consciously planted. There are a sort of an application that I personally have built. I wanted to show you just to give you a feel for what they are. We will sort of go outside of the zone of HPCs and quantum computing and AI and try to bring a few of these technologies together, which is what I would call as the convergence. So there is something related to immersive tech that I thought you all need to know about, because many of the leading consultancy firms, everyone has predicted that yes, while today's DeepSeek has caused a huge disruption in the world of AI, very soon we are going to see a lot of convergence. Hyperconvergence is a terminology that I'm sure most of you academicians would know, researchers, students might know, where storage, compute, and networking coming together. We are going to see a lot of convergence in technologies happening. So I've got a very interesting demo of how immersive technology with AI could really augment and change the way engagement to users, learners, customers could all change the way. So as I said earlier in my first session, I come from the finance background. So I would give you a flavor of immersive technology as well. So a lot of interesting stuff. And before I go away to start sharing my screen, I also wanted to mention that all of this fancy world of technology is great, but if we do not have the right level of governance, we need to care about the sort of calls that we get, right? How many times each of us get international calls? So many attempts to cyber attacks are happening. I just heard the previous speaker alluding to password protection and encryption. There is something which I have created around largely to spread awareness around deepfakes. What happens with the current world of generative AI, how with a few pieces of text and my image, just my photo, and a voice of a personality, how all of this can be combined to really simulate as if Ajay ji or anybody of you are talking. Impossible to believe, right? So there is one video that I have got. I hope Murphy doesn't intervene. I'll be able to show all of these applications to you. So it's going to be a hopefully a interesting session. I consciously added these demos considering that post lunch plus period. So if you have your cup of tea, please bring them along. With that, let me share my screen. Okay. So general nod that you're able to see my screen. 1 thumbs up, 2 thumbs ups here and there would be good enough. You're able to see my screen. Yes, anybody?
Yes, sir. Visible, sir.
Okay, visible. Okay. Just a minute. I need to share my audio for the application. Also, I'm going to reshare. Sorry about this again. I have to share my sound as well. Okay. So now let me share my screen. Hopefully it's all visible. Participants can now see your screen. Fantastic. So yeah, so the next 40, no, not 40, for 60, 65 minutes is largely going to be around the future trends. As I said, I would not go into that much depth, but then there is a lot of depth that you would get to see around the AI front. So as always, considering that most of us are employed in firms, I would spend 30 seconds for all of you to go through, which is a disclaimer, which is important for some of us working in companies to have it. So I'll just spend 30 seconds on it before I move to the next slide. Okay, with that, let's quickly jump in. So I just wanted to start off with most of you. If you're in the field, if you're in the industry, you would know this particular graph that you see here, which is traditionally called as the Gartner hype cycle. Before we deep dive, what are the industry experts who are assessing the technology are talking about? And this hype cycle exactly tries to portray that. So if you see on the x-axis, there is an innovation trigger, peak of inflated expectations, trough of disillusionment, and then we have slope of enlightenment, and I think the plateau of productivity. Yeah. So what are the various technologies that are going to really hit us in the 2 years, 2 to 5 years, and then beyond, 5 to 10 years? The first things, let's get our attention on to what is being said in the less than 2 years area. The circle that you see here, which is the circle without any color. There is GitOps, which is going to be the peak of inflated expectations. GitOps, I'm sure many developers out there, it's like having your Git repository as a central hub, wherein you any change that makes onto it automatically triggers any of your CI/CD pipelines and instantly ensures that every change is reflected in the real environment. So that's something which is going to really see a lot of traction on that in the GitOps area. So that's the small dot that you see with my mouse. I'm trying to hover over it. Any other technology that we see in the less than 2 years? Not many in terms of the growth that we see in the next couple of years. But what we see here is generative AI is something that is really going to get to a point. It's hitting the trough of disillusionment. And what does that trough of disillusionment mean? It started off with a lot of expectations, went to the hype curve that you see here, which is the peak of inflated expectations. Now, organizations like mine and every other industry are looking to see, can generative AI generate those promised efficiencies? Can it really help me creating revenues? So that's the area where it's going to be seriously tested, which is what the trough of disillusionment is. And once we have some credibility, some of them get lost here itself. They don't go into the slope of enlightenment, but we do not know where generative AI will head into. So that's something that we see here. WebAssembly, WASM is what we call. It's a binary code based. How do you make your browsers to quickly respond? That's another area that we see. We're going to see a lot of traction. There is going to be AI augmented software engineering. That's again going to be another area of development. A lot of expectations on that. Internal developer portals. Again, if you're coming from the corporate side, if I am a developer, application developer sitting here, can I open up a screen and have every access to any API I wanted? Can I have access to all the software development toolkits? Can I have the cloud architecture available with me? Can I not bring all of them together? It's like, you sit in front of a 365, Microsoft 365, where you have your PPTs, Word, Excel, right? The same thing. That's another area which we are seeing a possibility of development, internal developer tools. And likewise, many of these, some of these technologies that we see here. I wanted to consciously take your attention to this greater than 10 years. Again, this is a report, as I said earlier in my previous session, everyone is an expert. They have a view. We all need to validate the view. What they are predicting, the Gartner's experts here are predicting is this is like humanoid working robots is something that's going to take a little longer. Cybersecurity mesh architecture a little longer. 6G, artificial general intelligence. If you see this yellow color triangle, it's going to take greater than 10 years. That's something that they have predicted, but I think with what we had seen, a sudden disruption where DeepSeek has just like that come off, right? Where it countered the sort of need for huge infrastructure required to train models. Such things might happen, and many of these, instead of greater than 10 years in terms of the development cycle, could actually happen much earlier. So that's the general trend here. I don't want to miss out on something here, which is AI supercomputing, which is very much there, as you see here. We've been speaking about in the last session, El Capitan, Aurora, all those huge systems. AI supercomputing is very much required for us to subject it to huge amount of data so that we are able to predict with whatever use cases that we throw at it. So that's what I would want to just get you a glance or glimpse of all of this. With that, this is a little deep dive of what we had just seen. GitOps, as I said, which is going to be in the less than 2 years time frame. I don't know how many of you have heard about this AI Prism notion. So this is largely about any AI application that we have. It cannot act independent. It needs to have a trust. It needs to be governed by the risks that comes along with it and a proper security management framework. So which is what the AI Prism is. Every AI application, even the government of India has been coming up with their own acts related to how data needs to be managed, how applications pertaining to AI need to be built. Going forward, this is going to be a constant. Disinformation security is another area which we spoke about, deepfakes, which is why I've also planted a specific video on that, which is disinformation, as the name suggests, simply giving information which is not true. So how do you manipulate the information, which is where disinformation is, and how can you safeguard that? Prompt engineering and all of that are very much there. This greater than 10 years is AGI. We don't know, this could even advance further. But what generally we need to look at is within the 2 to 5 years, this area on the side that you see here 2 to 5 years, this is the area where there's going to be a lot of traction that's going to come in. Immersive technology is slowly going to come up, which is where the digital twin of a customer. I have again another application to show you what it means to build your own avatar and make it available for people to see. So that's the digital twin, which is also expected to create much more immersive and engaging responses in the next 5 to 10 years. Agents, we have a demo of agentic AI. I'll talk about what agentic AI is when we get to that section. So that's something which is going to really have a lot of impact on the industry. Homomorphic encryption, which is largely to do with, I don't want, if I have to do some task or an action on my data, is it something that I can do it on the encrypted data? Can I not train on the encrypted data so that I don't need to lose out any privacy on that? So that's another area, a lot of research is happening. Federated machine learning is one more technology. Rather than having your you have your own local systems where you train sensitive data and only bank upon the cloud for doing high compute operations, which is the notion of what federated machine learning is all about. So that's another area that's coming up. Spatial computing is sorry, similar to your digital twin, where the reality and what's going to be on the immersive side, the metaverse that we say, kind of converges. So spatial computing cannot act on its own. We need high-end computer systems to really help support spatial computing. And even if you really wanted to have it on devices, mobile devices, 5G, or even the adoption of 6G will make it super fast. So with that, let's go into a little bit some of the concepts that we got introduced. I just wanted all of you to be sort of savvy with it, so which is where I have just put up this. So we spoke about GitOps, which definitely most of you, if you're in an maybe in the university also you have, but then going forward, this is what is going to cause a revolution in terms of having a single source of truth in your Git, and everything around it will be managed automatically. So any change to the infrastructure will automatically be reflected in the real environment. So that's what is GitOps. Disinformation security, we spoke about that. How do you spread false information? Digital immune systems. This is more on how do I build systems today to prevent any cyber attacks? One of the parts that the previous speaker I just heard him talk about is some encryption of your password. That's very much required. And now we're talking about discrete systems. How do you really build information security into applications that you create, right? That you code upon. So that's an area because of so much threat that we are seeing on the cybersecurity front. So that is another area. Federated machine learning we spoke about. Decentralized approach where machine learning models across multiple devices, you don't share your data. That's the key part. Whatever you wanted to train your data, it's only local model on your own system. You don't pass it on to a central cloud. Who knows, right? These days, everyone is building a machine learning model, and what's the guarantee that your data is misused? So you just build it locally and only share the model updates to a central aggregator, and the central aggregator could be on the cloud. So that's something which is going to come up in a big way. We spoke about homomorphic encryption, computations happening on encrypted data. See, some of these points that I'm mentioning would also be potential areas of your research, because that was another point that we spoke about that I'll be speaking about towards the end. Anybody interested and who are veterans of this, being a master of all of this is going to be very, very difficult. Some of you may be specific on deep learning, machine learning, some of you around encryption area, cybersecurity, that could help. Large action models, this just came up, it sprung up of late, where you're able to use your computer programming code to handle instructions. So for example, keyboard typing can be handled efficiently, which is where the large action models come in. If I wanted to switch off the system, or if I wanted to perform a specific action and not like generating a text, right? Performing an action through machine learning is what LAMs are all about. So that's, if some of you are interested, that could be a research area. Machine customers, too much of a technology. If you have watched some of the sci-fi movies, it's going to take some time for this to really evolve. Essentially, what it means, folks, it might sound as sci-fi. You have your AI agent, your digital twin, which will make the purchasing decisions on your behalf. It's not you. So you can effectively use your time for something else, but you would have given rule-based instructions or some sort of a machine learning-based instructions to it to take decisions on your behalf. So that's probably will take a little more time to evolve. So these are the key technology descriptions. Now, getting a little deeper now onto what are the CIOs in the organizations today are thinking. This is an important question, right? I mean, we are running many of the folks who had been speakers here, chief information officers, chief technology officers. What are they thinking? What areas? What are their technology priorities? And we can imagine so many technologies are around. What is the primary focus? So that's this is for 2025 and beyond. It's disappointing, personally speaking, that quantum computing, if you see at the bottom and starting from the bottom, if you see what this means, the dark blue here, it's already deployed. The lighter gray, which is like within the next 12 months. And I think we don't need to see beyond this blue, which is between 1 to 2 years, 12 to 24 months. Quantum computing seemingly has taken a backseat, and I wish it comes to the forefront. Now, why it has taken a backseat, I don't know. Maybe, in fact, this was one of the questions that was asked. Do today's El Capitan, Auroras, and all those systems that we have, high performance computing, would they be capable enough to handle the exascale computing requirements that, your much more than exascale computing requirements of qubits, which changes states, indiscriminately, I would say. So maybe it is still not there yet. There are a few industry players who are working on quantum computing systems. I think Google's Willow is one such that got developed. So, but then there is a lot of research and experimentation happening. And if you see even the previous slide, quantum computing is a little way ahead from the overall development. So maybe it might take 5 to 10 years to really see some development and growth around this. But what is leading on the top? See, this is 43% plus. If you say 30%, we are literally looking at around 70-75% of applications are going to be, AI is going to be industrialized. And 3-4 years back, in a similar conference like this, not online, I was in a session, panel discussion, and most of the business side people said it's a fad. It will not really kick in. I'm talking about generative AI. They were really hesitant to even deploy the classical machine learning solutions. And they were taking it very, very cautiously. But now today, as we are seeing the way things are progressing, there is no guarantee that any technology you deploy will instantly give you results. But looking at the traction, everybody do not want to be like, I don't want to miss out on this opportunity, whether it is efficiency gaining, preventing frauds, assessing risks in my systems. A lot of the CIOs, chief information officers, technology officers in the systems are looking at AI as a platform. Low code, no code is also another one, which is which will definitely see a big uptick going forward. Generative AI is very much there. My personal view, this is not my organization's view, my personal view is generative AI is, as Gartner's curve also really says, right? It's come to a point in the next 1 year, 2025, end of 2025, we will get to know, does it really generate revenue? See, it's okay to generate efficiency. My costs are coming down, but can it generate revenues? Is something which will be put to real test. But I believe it has enhanced the productivity of many of the developers here. I'm sure in your college as well, or wherever you are working, Copilot has simply eased out the way we build code these days. So that is something in terms of a clear-cut winner in terms of productivity gains, but will it generate a revenue? Can I use this technology for that purpose? Is something which is very crucial to see. Everything else, I would just go about reading it. Industry cloud platform, if you know what an industry cloud platform is, these are cloud platforms which are very focused on a specific industry vertical. You could have a dedicated cloud platform for, say, medical domain. You could have something for an insurance domain, different fields. So that's, if you go to a vendor, they would say that, hey, I have got all the frameworks necessary for handling healthcare domain. So you can come to me and then have your application deployed. So that's another area from a cloud perspective. Domain specific is seeing an uptick, a good number of 50%. If you see here, 35 plus 11, it's 40%, 46%, close to 50% is what we are seeing, where individual domain specific cloud platforms are going to see a growth. Moving ahead, advanced distributed cloud is, as the name suggests, it's completely made available across the geographies. Other things you can just skim through. Immersive technology is catching up, folks. There will be a time, and if you mark my words, this is something where it's going to transform the way we decipher, we see things. This is another technology that's really going to have a bigger say with high compute. Coming up and supporting it. Immersive technologies will definitely see a big uptick going forward. So with that, let me quickly get our focus onto compute specifically. We saw overall all the technologies. Now we are just focusing ourselves on compute. Where does compute take us from here? So there, if you really look at it, the too many terminologies, we'll just try to get into. I am no expert again, folks, on most of this. As I said, I am an AI, Gen AI person. We do touch upon some of this with our infrastructure team, but I do keep reading a lot about many of these technologies. So, but I've done my best to give you a glimpse of what each of these technologies is. And again, I'm saying this because I would like you all to pick up some of this if you're interested in your future research direction, publishing a paper. There's a lot of paper that are being published on some of these compute technologies. But just quickly focusing on the red round ones that you see, AI supercomputing, no change. We saw that very much there. It's something where we are going to see a big proliferation in the 2 to 5 years. And this is where I was saying quantum computing is, in fact, in this, it's pushed to 10 years down the line. I hope to see that accelerates a little earlier, but that's the sort of work that need to be done for us to mature into the space of quantum computing. Every other area that you see, devirtualization. So devirtualization, as some of you on the infrastructure side might know, virtualization, you have these multiple layers where your memory, your compute, all of that gets shared across. And that's where your hypervisors are trying to, unfortunately build in so much of latency, causing delays. Some of your VDI systems that we have, some of you might have used. Devirtualization is trying to completely eliminate that. So that's another area if somebody on the infrastructure side could look at. Compute Express Link, in the last session, we spoke about interconnects. The good interconnects that we have, the latency gets reduced and the faster in terms of data processing speed that we would have. So that's a lot of vendors are coming in this space as well. We will see a little bit of some of these in the subsequent slides. What I would do now is quickly take you through each of these verticals and see what we are heading towards in each of these areas. And again, if you are interested in any of this, these would probably act as your research topics. So let me start off by saying this. Again, this is my view. And of course, we have many of these consulting firms talking about it as well. What is the future? Is it going to be on-prem? Is it going to be cloud? We are talking about application-specific integrated circuits. Is that going to dominate? Would quantum come in? The general opinion is going forward, we will probably be heading into the era of hybrid computing. It's like horses for courses, right? Based on your application need, it's a combination of your CPUs, GPUs. Are you going to be supporting more of your edge computations? Then those specific underlying compute will be put up. Neuromorphic is one good example here on the right-hand side that you see. That's more about how do I create my computing application resembling the way how my brain functions, my neuron functions, the way that it computes, right? How do you synthesize that, simulate it, and create a computing environment out of it? So that's another area. Photonic is using your light waves. How do you enhance the speed rather than the traditional electrons on the chip that you have? Can we use for light waves to reduce latency, make a highly energy efficient computing environment? So, but the end of the day, and bio and carbon is more on. In fact, some of the companies. This is also a good topic for research, and I'm no expert on that. But just to put it forward to you, some of the companies are really looking at how DNA could be used to build human DNA. I'm talking about how that could be used to, build computing environments. So I've not gone into the depth of it, but there's a lot of, and then there is something around this carbon neutral energy efficient systems. It's another very good research specifically on the sustainability space. So the essence that I'm trying to get to here is the future, according to me, is going to be a very hybrid computing model or hybrid computing architecture, depending upon whatever use cases that computing power will be turned on, and the rest will still be there in the environment. So that's likely to be the orchestrating tire for the hybrid computing. Now, a lot of stuff, don't worry, just be with me for some time. When we get into AI, there will be some of those. As I said, I've got some POCs. I've got some applications that I've built that I will show you. But because we also need to touch upon the concept around the high performance computing and quantum computing. I can't experiment and show that to you here. So which is where we are talking about a lot of stuff, but I'm sure these will be great takeaways for many of you from a research perspective. So coming again and reflecting upon emerging memory technology. So these are the ones which are, if you saw on the left-hand side, we all know our traditional RAM, DRAM and NAND. Now we are looking at magnetoresistive RAM and ReRAM as a new next generation of memory solutions. Some of the companies in the today's world, vendors, have tried way back in 2015. I think it is Micron. I don't recollect exactly the full name, but they have failed. So the whole idea here is, how can I build newer forms of next generation memory solution to enhance my performance and efficiency? Because writing to memory has an input-output operations. All of you know about it, right? So how can I do it faster? Now, getting into the details of magnetoresistive RAM and what it has to do is your research that you could look at. But that's very good an area. Photonic computing, we spoke about it, using photons instead of electricity. It's a very good concept. There are good number of Chinese and Taiwanese companies who have already created a chip, which is a photonic chip. In fact, if you probably Google and find it out, there is a specific name of this Taiwanese company who have built that chip, and they have proven that it provides unbelievable levels of performance with very low energy consumption. And when I say performance, I'm talking about data processing. So that's a very good area. I feel that photonic computing will also kick in quicker, looking at the way HPC evolves, and photonic computing also evolves in that fashion. Meta computing is a very strange name. Basically, it's all about combining multiple computer resources, right? Something similar to the hybrid computing that we spoke about. AI supercomputing is very much required in the sense that in order to train models, you really need massive data sets. You really need top end compute for it, right? So that's where AI and supercomputing will always come together. Devirtualization, I was just mentioning about it. Too many complexities today. I've come across since the time, 1996, I think, when I started off, we were given dummy terminals, which only did what it could do, to evolve into personal systems, and then to Linux systems, and then to today, unbelievable levels of what we are seeing, and VDIs, VPN laptops, and it has its own challenges. Devirtualization is going to hopefully take us to a point where it helps us to prevent those delays that we see typically in the virtualization environments, your hypervisors I'm talking about. So that's related to this. I won't go into depth of it, just to give you a feel for what I was just talking about earlier. Emerging memory, what is being said is magnetoresistive RAM and ReRAM, if they have a full level of development, they are really going to be having an impact on the IoT or edge computing areas. So that's something which we will see, because naturally latency, the lowest level of latency is what is required, right? So which is where these sort of chips, new memory capable chips need to come in. Photonic computing we spoke about. I don't recollect the Chinese or a Taiwanese company name. You may Google out for it, please. Meta computing is straightforward. Devirtualization, we just spoke about it. If you get this devirtualization done, I can use VDI for my gaming requirements, folks. In VDI, in some of the firms, even simple training, forget about training a full end foundation model. Even letting the classical machine learning, if you run the traditional LSTM or anything, it bombs, because VDIs have limited capabilities. So, but I hope devirtualization is hopefully going to change all of that. Moving further onto the other pillar, in terms of what did we see, there very so much of hype, but we don't know whether it will really lead to whether it will be able to handle all the challenges. Consumption-based models we saw. I don't know how many of you have worked in AWS Lambda. It's serverless architecture. Instantly, it finishes your job and you'll be able to get your application responses. Brilliant to the core. If you have not used it, you should try. I'm a big fan. but then it has its own limitations. And I have to give you this example. Sometime back in one of our hackathons, we were trying to, if you're familiar on the AI field, we were trying to load a data set, huge data set, and then split it and then embed it. And we were wanting to do that on a Lambda function. And if you're an AWS certified people or expert out there, you would know what it means. There is a time limit for all these Lambda services. So not all there is, I think it's 10 minutes if memory holds good, or 15 minutes. But then when you're processing a huge data for uploading and then breaking it into text chunks and then pushing it for embedding in a vector DB, that process on a Lambda for huge documents, not possible. It has its limitations, but then very economical. Time will tell how, maybe that was not the right application to be on a Lambda, but you need to pick and choose how such serverless applications will come in. Direct to chip liquid cooling, I frankly didn't have any idea on this. But then there are a lot of good videos which I would recommend you folks to talk about or go through. On the internet, they have used new technology. I think it is one of the top end hardware manufacturers. The entire, if you remove your desktop, your hard disk, and whatever comes out, right? I mean, you just imagine dipping itself onto your onto a liquid. And instead of your traditional fan or processor that we see on all our laptops, this is like very amazing from what I found. So that's another area which we do not know. Is that the way forward? Will it have any other impacts? No idea. Time will tell. So direct to chip liquid cooling is a very interesting area. The other ones are, I'm just going to skip Computer Express Link. We just spoke about high speed interconnect, which we spoke about some time back, right? How do you share your memory across these various nodes? That's where the Compute Express Link comes in. Confidential computing, protecting sensitive data through encryption. I don't need to decrypt and then put in my compute. So how do I do it effectively is what confidential computing is all about. We just spoke about this as well. So in interest of time, I will just skip this. Moving to the next tier. And again, some of you are noting down, these topics are very interesting. And as I said, I'm not on the infrastructure side. I'm on the application side, but these are revolutionary topics. If at all you really wanted to do some research, there is something called eBPF. This is also something related to a technology where you'll be able to monitor real-time networking, network monitoring and security, eBPF. But we do not know whether it will sustain for a longer time. If some of you out there who know about this technology, you can pick that up. Quantum computing, we know what it is, using qubits, where the state is undefined. I toss a coin, and I know it's going to be heads or tails. But what if a specific instances could be a head or could be a tail, right? In a simplistic way. So that's revolutionary, but the expectation is it will take some time for it to evolve. Neuromorphic computing, I spoke about it. It's in terms of mimicking your human brain. And it's something, how do I use that to build architectures? And it's largely useful for your robotics and sensory devices. We spoke about FPGA, if you recollect in the first session, functional accelerator cards. That's another area which we will have to see more advancement happening on the technology. And this deep neural networks and ASICs are always connected. So I hope to see something like a TPU. There could be a ZPU that might come up to help us all. Again, machine learning people out there, how much of difficulty that you would have faced in training your applications. Hopefully, this is going to simplify that. Bear with me again, because this is important. I'm just taking you to the last part of compute before we jump into very interesting topics, at least from my end. Things that are really happening very well, slope of enlightenment, where it's going to mature for sure. Implementation is going to. We all know about container management, bare metal as a service. I used to work at Oracle in 2003, 2000 to 2003, where we used to have a cluster of machines, and we used to deploy Oracle database on all of this sitting in a central system. This is 2003. Some of you might be hearing, that's like so easy for me. In 2003, Oracle was planning that, and that was like bare metal provisioning. So I sit here, I decide on my system, it will monitor, these are the systems. Does the system wanted this OS? Okay, we'll provision that OS. This prerequisites, all of that will be checked on that specific node, and the entire solution would be installed. All of that has evolved, and today we are talking about BMAS, which is going to be good. So, if that's going to be available I can go to the cloud and get a BMAS, do a deployment in such a manner that I can do my gaming or big data analytics. So that's an area which is going to see a lot of traction. Cloud tethered compute, immersive cooling, we kind of spoke about in the previous one. Number 5 here is more on technologies which probably most of you are aware. OS containers. See, these are operating specific, system specific containers. These should be seen differently from the DevOps containers that we know, Dockers. It's while it is saying that Docker is a specific example here, the OS containers are how can I customize my operating system instructions in such a manner that I don't impact my kernel. So I still have my kernel, but then I will have the cushion to make customizations on some of the other dependencies. So that's what is catching up. MicroOS is further down that area. Rancher OS and Core OS is an example, something similar to OS containers, but it is at a much finer level. And then we have hyperconvergence, integrating compute, storage, and networking together. That's the sort of a future that we are looking at. Don't worry about all this. I'm anyway going to share this information. You can read through it. This gives you some feelers for why do we really, for example, if I take neuromorphic computing, what is it, how is it different from the traditional architecture, right? So how is it going to be different? So all that you could read, highly energy efficient if you design your architecture, computing architecture that way. So likewise, I've given for all of this, this is for an easy read, not to sweat in this call. Kind of shifting gears quickly, looking at the time that we have. Quantum computing, 10 years is what we heard. I may be wrong, and I wish I was wrong. But then a lot of technologies and consulting firms are talking about that this is how the trend is going to be. There is a short term, there is a mid-term, and there is a long term. And if you see it, we are talking about a 10-year horizon from 2024 to 2035. And the potential will slowly, this worm is going up. Now, what is optimization, computational chemistry? We will just quickly go through the slide, but all your takeaway from this is it's very much there, a lot of research happening. Things could accelerate it further, but for now, going by the pace of technology, it is a trend that we will see in 10 years down the line. Now, in the previous slide, you saw that what is immediately going to happen with quantum computing? What is this optimization? Optimization is all about where the focus is on solving all the optimization for the supply chain problem, your Zepto delivery, and Zepto is just an example I was giving you. You can solve it in traditional machine learning supply chain itself. But then quantum computers can do it much more effectively. So short term, these computers, as they evolve, will be helping to solve optimization, computational chemistry, largely in terms of simulation of molecules for drug discovery and material design. So that's where it will be. Medium term, how is it going to stretch itself? We saw about the grids. We spoke about the grids in the first conversation. The smaller the grid, the greater is your ability to process information, and you can expand and extrapolate across when it comes to weather patterns. So that's something which quantum systems will be able to do it much better. So gradually you will see physical systems, which is like the weather patterns being simulated on your own computers, on your quantum computers. Quantum algorithms will also come up, which will help in unbelievably faster search across huge databases. Data is exploding, as all of you know, and every day things are pouring in. So how do we really process all that? Hopefully, quantum algorithm is the solution for it. Long term is long term. People say AI will get abolished with quantum computing, but I don't agree, because if I have to really predict, there is going to be multiple permutation combinations. All it's going to happen is my processing speed will be much, much higher, and I will be able to train huge volumes of data. So machine learning and quantum computing will definitely coexist as a technology. Factorization is a common problem around cryptography that will also see a new significant implications going forward in the cybersecurity space with quantum computing. Busy slide, don't worry about it. All I'm trying to capture here is who are all the various players on the quantum computing side. The biggies are doing what they are. Google Willow, I think I said sometime back. So that's something which we are going to see. Amazon, Microsoft, everybody has got their own research that's going on. Couple of research interested me, and I'm just going to put that in front of you. Xanadu is a Canadian startup. We will see what these guys are doing on the photon computing. And then each of this, what does this mean, is something that we will see in the subsequent slide. So the biggies, as what we see here, they are using supercomputers and trying to simulate and trying to build their version of quantum computing systems. We are also seeing some of these, like Google, working on Sycamore. They are, using ultra cold electrical circuits. The last time I read, like 2 months or 3 months back, out of my own interest on quantum computing, D-Wave seemingly has been said as one of the top-notch quantum computing systems, but I may be wrong. But this is something which is very much there. They basically use their architecture uses ultra cold electrical circuits. There are companies, Alpine Quantum, I think, and IonQ, you saw in the previous slide. Where is that? IonQ and many more of them. They are much more looking at what could be the foundation of quantum computing. What would be those? So that's where they're using suspended atoms in laser grids as qubits to look for how could we evolve trapped ions in building a quantum system. We spoke about photons, qubits. This is very, very interesting area, and I keep repeating this. It's really going to revolutionize Xanadu. This has come in MIT Technology Review. If you folks are not subscribed to MIT, you're missing a lot. My suggestion is read through what, again, there are great Indian universities who have their own subscriptions, but it's not to say that MIT is the best, but they have excellent technical material on any field. So you can look at it. I'm not promoting MIT, but more from a knowledge perspective. So there is this company which has come up with something unique. We will talk about that in a minute. And there are many other methods in terms of work or research happening on the quantum computing side. This interested me a lot. I didn't study much about this. Element 6, it's using diamond impurities. Maybe another area of research if you're interested in writing a paper. So that's pretty much on this one. And I think, yeah, this would be the last slide before I take a pause and we will jump into AI. So this is a very interesting case study about this Xanadu. And they are using, they're trying to build a photonic quantum computer. It's basically, as I said, using light waves, and which is different from what a traditional quantum computer is being built by IBM and Google are. Now, what they're claiming is their current capacity. It's just delivering 12 qubits, but they expect it to enhance it, as you see here, gradually to a huge number, million qubit. Now, what does it mean with respect to the biggies? Of course, this is a startup, not something like they've got enough infrastructure to build a lot. Google's Willow does 105 qubits, so there is this comparison for you. But it's been written by a lot of investors are pouring in money into this company from what I read about the research report. They are looking at improving their photon quality, enhancing it to match up and then gradually grow beyond these numbers of qubits in terms of their ability to process. So long term, a million qubit capacity by 2029, which will be close to 2032, 34, which is like 7 years or 5 to 7 years from now, where we will look at this company probably getting closer to what we would like to see an ideal quantum computing system. So if you're interested, you can go ahead and read through this as well. So I'm going to take a pause here, have some water, and maybe Mr. Jay, you wanted to do a quiz at this juncture, that will be ideal.
Right, sir. You please take a pause. In the meantime, if participants want to take a pause, they can also. And I will search for a quiz and we can do one question.
So things are going to get exciting from here on. I'll just pause for another minute. So I'll wait for you to give me a go, and then we can proceed on the next set of topics.
You can proceed, sir.
Excellent. Thank you. Thank you very much. Thank you, sir. Thank you so much. All right. So this is an area which I am so, I should say, I associated with for a good period of time. If some of you haven't been familiar with my background, I lead the Innovation Now Next team division at Nomura, which is a Japanese investment bank based out of Mumbai. I work from Bangalore. I keep shuttling to Mumbai often from Bangalore. Now, why I was saying about this is for the past 10 years, I've seen how AI has evolved, all the false promises of AI. And now we don't know with DeepSeek, I spoke about it. Is that something going to be a revolutionary? Time will tell. But the whole idea or what I do is to bring in the latest and the greatest technologies around AI and proliferate it and see what sort of business problems that it can solve, and then take it to the next levels. And I have to say this, that the last 3 years have been, you call it innovation, you call it CTO, you call it CIO, Chief Digital Officer, all of them should have been on their toes, because the rapid change that we have seen in the world of AI has been phenomenal. Somebody remarked at me saying that classical machine learning, what did we do? Why are we learning reinforcement learning? And all those LSTMs, and no, they're very much required, because those are the foundation building blocks to today's generative AI. So with that, let's again start looking at, because this session is more focused on future, the trend, and what the firms have to say. I just wanted to present this, the top 10 specifically onto AI. I'm sure many of you are familiar with what an agentic AI can do. Don't just go back in time on that movie Matrix, where you find agents coming out. We have not gone to that era yet. That Matrix is hopefully not there. These are still agentic AIs, which has come in proliferation in the last 6, 7, 8 months. It's come in a big way in terms of enabling decision points where you'll be able to automate your tasks and synchronize the tasks. It's not like I finish off a job and I sit. The agents can communicate with each other much more effectively. So that's something which has been said as a trend. I have a demo for you, live demo. Hopefully it works. Sometimes when you do a demo, things bomb, but hopefully it works. A very simple demo on what I'm referring to agentic AI. AI governance platform, we spoke about the TRISM, if you remember, trust, risk, and security management. That's going to be inherent in everything that we do. Disinformation security, about the wrong information that gets passed on and percolated, causing a lot of harm. So that's something which is going to be very much there in the radar. Post-quantum cryptography is a new feature. I don't know much about it, but what I can tell you is it's something where we keep saying that quantum computing will be super quick enough to figure out the multiple states that it can be, the qubits can be. Now, which means that if I have a password, can I break the password in how much time? With quantum computing it can break the password very quickly because the combinations that it can put in is super fast or hyper fast. I don't know what's the better word than hyper. But then do you have a cryptography that will prevent? I know quantum computing is going to come 8 years, 10 years down the line. Can it prevent? Possibly, yes. So that's where the PQC comes in, post-quantum cryptography. Ambient invisible intelligence, we'll speak about that shortly. Energy efficient computing is going to be there. Hybrid computing, again, if you see here, we spoke about compute cannot be standalone. It's all going to be GPUs, CPUs, and all that. So that's another area that's coming in. Spatial computing will really reduce the physical and the digital world that we live in. How many of you are Pokemon fans? You tried or attempted during the unfortunate COVID times? I don't know. But that's proliferated, and we are seeing a lot of action. Gradually, we'll see a lot of action on that front, spatial computing. Polyfunctional robots are a little on the higher side, and the neurological enhancements is another area that we see a lot of changes that are going to come in. Now, let's quickly get into agentic AI, a very interesting subject. So what does this mean? And when I say low agency, if you see on the screen, and then high agency, traditionally, it's like, if somebody says that, what big deal? I mean, I can write a code that completes a task and comes back to me saying success or a failure, which is what expected of anything to do, right? I mean, RPA, the fancy word that many of the industries have used and still using, it's robotic process automation. People said that it's like bots going to be available. They will read an Excel file. They will take information, read the screen information, screen grab it, and then process all that you wanted, put it in. Absolutely nothing need to be done. No, that's existed, but they were all rule-based, manual, repetitive tasks. Rule-based, manual, repetitive tasks. But did they have some level of cognitive intelligence? The answer is no. Because at the time of RPAs or some of those codes that you would have written in Python, Java, or whatever language did not have that sort of efficiency or intelligence that today's large language models provide. So which is where the difference of low agency and high agency comes in. Now, high agency, by the way, is pure human. If you see these black dots, they are very adaptive, because if you put a human to do a job, obviously, right, we have a brain and we sense it in terms of use it the way that we need. Reactive, which is like, low agency is, we are proactive planning, we manage complex goals, we do complex environment, and are to a larger extent autonomous. But if you see the in-between part, the green ones, this is where the LLM-based assistants come in. They are kind of getting in that zone where we feel that some of these tasks can be automated, not on their own, because we don't want a situation that happens in sci-fi movies like Terminator, where everything takes over us, but still have the human in the loop. So that's where these agentic AI agency gap is what, as you see on the slide, is referring to. So somewhere, can I be reasonably adaptive? Can I be more proactive? For example, if a customer makes a call to a customer service center saying there is a delay in this delivery. Many of you might have ordered, I don't know if you have Samsung Ultra S25. If that doesn't come up, right, the customer service person understands, not just that I have to respond to him or her, the customer, with when the delivery is going to come, but have much more information, understand his tonal variety, and probably do another additional cross-sell or an upsell automatically. So how do you generate that information? How do you get into that sort of a natural language processing capability, which the existing applications lack, and only LLMs are having it at high doses? So that's the sort of a difference that AI agents come in. And on the left-hand side that you see, we have 15%, 2028, the prediction It's 15% of all the day-to-day activities are expected to be taken over by agentic AI, as in autonomously handled by agentic AI. So, and how is this trend going to gradually change? And we are now talking about generative AI specifically. By 2027, we look at a lot of domain-specific applications being built. 28, we are just going to see from 10% of AI use cases, generative AI models are expected. If everything goes fine, guys, I mean, there's a lot of ifs and buts, but the prediction in terms of a trend says that 50% is what open source generative AI models will take control. 2028, we are again going to see when so much things happen, right? Governments need to act, and which is exactly where the regulations come in, and which is where we are going to see very much of an active regulation in the era of 2028, and gradually. I don't know why this is not changed, but yeah. So we'll have to see a lot of regulations coming in, a lot of changes that are going to happen. More of autonomous and semi-autonomous AI agents are really going to dominate. So we spoke about what agentic AI is at a very high level, extreme levels of autonomy. The word extreme is something very subjective. It depends on the business case that we're trying to solve. They're very goal oriented. I need to compare this company and that company and generate a report. If that is a goal given to it, it will try to do it at all costs. So it's very goal oriented behavior. It will interact with the environment. Now this environment can change, and it will be able to adapt and understand what the changes. You don't need to go back and manually change your code. You would have put in conditions in such a manner to make it environmentally interact with the existing environment. The learning capability is high, and workflow optimization can also be done. And it's like combining multiple agents to completely do a single task. So with that, too much of talk. Let's quickly see an agentic AI example. Allow me to start my system. So what I have done, and I'm going to show you, if you're able to see my screen here, could you all see my screen? One more thumbs up if possible. Or somebody open up and say you are able to. Yes, folks. Yes. Okay, I take that for an yes, that you're able to see my screen. So what this is an agentic code that I have written. Now, what's the purpose of this is something which I wanted to show you here. So this is a financial analysis agent. Now, what is this trying to do? The typical chief financial officers of companies, they have a task to compare their company's performance vis-a-vis the other company, and then see what is going well. Is my cost of goods high? Is my revenue low, high compared to so and so companies? They need to prepare a report and make it available. An analyst has been given a job, or a senior financial manager has given a job to be presented to the CFO, who will take it up to the CEO. Let's say that's an example. Now look at the sort of processes that are involved here. What I'm going to also share with you quickly is just allow me to share this part. Do you see the screen here? This is this very simple information that I have loaded into. This is all what I have as information, which is 2018 to 2023 as an example. This has been my revenue of my company. Let's say there is my company that I'm running. My cost of goods has changed. My operating expenses is this. My net income is this. Now, this is all the information I need to feed into my agent. Now, what it does, and this is what you will see when I run it right now. It gathers this financial information. It picks up this data, this information. It synthesizes this, and it converts it into metrics related to saying how this growth has been 1 year on the other, how cost of goods has changed, how operating expenses have changed. So all the key financial metrics, it analyzes the data. And I would have also said that, compare this company with another company. It could be OpenAI. I'll show you an example of an OpenAI. Compare it with the research competitors that I mentioned. Is the research data that I receive is good enough? I spoke to you about human validation. It's not like you're outsourcing everything to the AI agent. I can consciously put a human validation and say, I'm happy with your comparison, proceed. I can put a tick and then allow it to happen. If I don't like it, I'll go back and ask it to do. So this loop that you see can go on and on and on. Then once it compares or picks up the data of, say, OpenAI as an example with my company, I'm assuming Sita AI, and it compares the performance. So two companies do the task. Now, when it compares the performance, it needs to now figure out, is this good enough? Everywhere we have somebody who will review the data, right? I mean, it's not like approved instantly. So you collect the feedback. If it is, if whatever you prepared is good, if it is not good, then again go back and collect additional information. And this loop that you see goes on and on and on. And this is configurable. You want to do it 2 times, you want to do it 3 times, 10 times, you can keep doing it. Every time it tries to improve the report in its best way. And finally, you will find a report that will be written. I have done nothing. I have just done this coding, which again, I'm going back and showing you. I've given just some of you who may be coders here. It's using LangGraph. And there is an agent state that we need to give. And this is the traditional prompt engineering that we do, gathering financial information, analyze the data, research the competitors, check whether the data is good, provide a feedback, again, go back and collect additional information and write a report in this form, which is what it is. And the rest of the code, I don't want to use this time to talk about. So let's go and run this and see what happens. So I'm saying analyze the financial performance of a dummy company, which is the Sita.ai, which is just a random company name I've given. And let's say OpenAI, I wanted to compare it. Now I've given 2 cycles, and these 2 cycles are how many times I want to iterate and improve my report. And now I'm going to say browse files, and I'm just going to upload the CSV, which is a very elementary data that I have sent. Now I'm going to do start analysis, and now the agent is in action. If you really see here, the agent is in action. It's running the analysis workflow. And gradually it will start putting in the results. Slowly, one by one. First, it's gone ahead and read this data, and it has processed this information. It would have converted into financial metrics, and it will slowly go into the one step after another. This is going to be a real future, folks, because many of those processes today, which can be automated from an end-to-end perspective, in not just in financial sector, KYC, know your customer, coming from the financial side, I can talk about that. It's an excellent process which requires so much of human intervention. With an intelligent bot like this, we will be able to completely built on our own. Now, if you see here, it has gathered the financial information and it has created this data point. You see this data as I'm scrolling down. This first step is done. It's gathered. It's beautifully captured that. It's computed how much is the change, revenue growth, net profit margin, which are all key metrics if you're from the finance background. Then once it has done this, let me close this. So it has also done the financial analysis. Now, if you see here, it's gone ahead, it's computed the data. Now, financial analysis is the next level. How was my revenue growth? How was my profitability? How did my net profit margin change? What are my efficiency metrics? You see all of that? That's been done. Now it's gone ahead, and I've mentioned OpenAI, right? It's gone ahead and collected information, making an API call. So it's collected this information. Now, which is the API? You may be wondering. I have for now using Tavily. How many of you are familiar? There's a lot of API engines available. I just wanted to show you this because I have consumed. Now the hit has come to 40. Earlier it was showing a smaller number. Now it is computed and it figured out from the internet all information about OpenAI, publicly available. Now you can change it to point to a specific database. You can change it to point to any other repository. So all this data information has been collected. Temporarily, I have given a pause because we don't have time. Human validation, I'm saying, I'm happy with you, agent. Go ahead. pick this stuff for me. Now, if you see here, the next step which has happened, and all of this, if you see this guy running, it's a Streamlit app. It's still running. It's still doing its job. It's done the very first analysis. What is Sita AI and what is OpenAI? How it has changed? What is, all these profitability analysis, efficiency metrics, all of that is being computed. Now, it's now going like a maker checker rule, right? Now we are going to do a feedback and critique on this first set of data that it has collected. If you see here, it says structure and clarity, what is there, what is missing, growth trends, what is there, what is missing, and it's looking for areas of improvement, suggesting what need to be done more. Believe me, all this additional information, what it needs to be done more, goes as an input to the agent, and it goes ahead and picks up additional search for all this additional critique that has come in. Look at this critique point. For every critique point, it has gone ahead and fetched additional information. And then it now used this additional information, and it has come back and said, now I have got the report. My manager, do you agree to this? The manager again looks at the new report. Because we have given the iteration 2, it's gone to the second iteration. It says it's largely okay. It's again doing a review. It says more stuff can be done. It again goes on to saying, okay, for this, I will again go back. I will hit my Tavily API, collect this additional information, come back, and then provide, look at this sort of data that it has collected second time. This is all going ahead and hitting the internet using the API, comes back and creates this the final analysis and a presentable final report. You just need to say send, which I haven't added here. This is the final critically evaluated report that could eventually be placed at your CEO's desk. And not just this, look at this, all the citations that are valid based on which it is provided or picked up this data is also made available here. So that's the beauty of having an end-to-end agent being built and making it available. So I'm just conscious of time. I think let me quickly go on to the next part of it. We spoke about disinformation security, deepfakes, impersonation. I just have something to show you here. So this is something which I have attempted to educate people about what happens, with so much of disinformation, deepfakes, very easily created. This is my picture, which is my corporate picture for my company. And I've just got, this is the PNG, GIF file, or whatever you might want to call, and this is like a few lines of text. I would have modified it for this session, but this is something that I had done for my internal company-related specific requirement. So if you see here, I've just said, hey, warm welcome, and you will hear this is a few lines of text. And I had cloned a very famous personality voice as if, that these words are being spoken by that personality. So just an image, a few lines of text, and a cloned voice of a famous personality. It could be any one of you out there as well. Now, putting all this together, I hope this plays. Let me know. So this is now converted the whole thing into a video. And let me know if you're able to hear the voice. I just need somebody to say, I am able to hear the voice. Otherwise, I need to reshare, please.
Good afternoon. A warm welcome to everyone present.
We
You
can
could hear the voice? You can.
Yeah.
Fantastic. So hear this out. It's just 30 seconds video of what I just mentioned.
Good afternoon. A warm welcome to everyone present here in the digital IQ session on generative AI. Hope you are all having a good start to the session on generative AI from Sita. The real Sita, I mean. Well, I am a fake, me in a different voice. Welcome to the dangerous world of deep fakes. This message you are hearing from me is a combination of 3 pieces of content put together. My digital photo image, a few lines of script, the one you are hearing now, and a cloned voice of a famous personality, keep guessing. Put them all together through a generative multi-model framework. We get an output video like the one you are watching. It's funny for sure. However, if it gets into the wrong hands, it's quite frightening as to what to believe and what not to. So just be watchful about deep fakes and the challenges of large language models. With that, let's get back to the session. This time with the real me, Sita, taking over. No more fakes. Over to you, the real Sita. This is your fake Sita signing off.
Thank you, fake Sita. So all, if you have understood the sort of challenge, right? Just the picture and a few lines, and I'm sure you all know whose voice is it. Needless to say, ex-president of US, Obama. And all it takes these days, folks, is even if you give a WhatsApp message, even if you speak 4 to 5 words, that's enough. That's enough to be cloned by highly sophisticated voice to text conversion, and then simulating the right modulation tone of your voice. And many of you, I'm sure, would have seen similar such fake IDs and people simulating things, all that news that we keep hearing. So very, very dangerous area. The whole idea here is to let you know that while technology is fantastic, but all of this could really happen.
Good afternoon. A warm welcome to everyone present here in the digital.
Sorry. So we'll just take another 5 minutes or 10 minutes more before I close. I just wanted to also talk to you about the other fantastic technology, which is around spatial computing. Huge opportunity in terms of simulating ourselves, and how do we combine AI, IoT, your mobile devices, supercomputing, HPCs. I'm not even getting to quantum here, and generative AI, all put together. Build immersive technology solutions. This is very much going to be a potential future going ahead. When I share the slide, you will get to see. So I just wanted to show you a glimpse of what I had created some time back. So this is like convergence of multiple technologies. Generative AI at the time was not there, but it is very much as a possibility. So what you see when I don't have time to play the entire thing, but I'll try to play it very quickly. So the context is this: we all invest. I'm sure all of you are wealthy millionaires who are there, and we all invest in banks, in stocks. And how many times all the investment comes in a large text or a document from the bank, right? I mean, how many times do we read it? Brokerages send that your portfolio. How do we really know? Imagine in a field of wealth management. What if I get a very vanilla wealth management page, which you will see, and I place it and I use my phone? If you're all able to see me, I am simply using my phone and create an augmented reality character out of it, and I'm able to interact, and I'm able to see how my portfolio will change. Look at the sort of a connect that your wealth, you and your provider of service will be able to interact in such a significant manner. So which is what the demo is. I will skip a few in the interest of time.
I'm your relationship. Quickly
So
go ahead and see how this application performs, this AR Wealth Report application.
So what you will see now is
Hi, Ms. Gayatri. A warm welcome to you, our dear investor. I am your relationship manager from Sita & Co. at your service. Thanks for using our augmented reality-based Wealth Report app. With a simple touch of a few access points in your Wealth Report, you would have an engaging experience to get deeper into your overall investment portfolio.
So I'm just going to pause here. If you see here, this entire thing seen from your mobile phone, a relationship manager popping up, and there are certain points here, and he's talking about thank you, welcoming you. Today it's my own avatar which I try to create. You can have avatars of your own, whomever you really wanted, assuming that they have given the permission. So that's the sort of a greeting that you get as the wealth manager speaks to you.
Investment tip about the specific advice offerings can be using C.
So they finish off, and
Wealth report that I have portfolio on it. After another, the first is that he or she on the screen. Now, as I was going to quickly go ahead and touch the share performance virtual button that you see there on the screen.
So if you're just seeing, it's just a small click. It's just taking a piece of paper and touching an object which says, it's just a text which says share performance, and instantly you see a video or a screen here, augmented reality screen, which talks about your investments, what you have done, how it has gone ahead, for various years that you have. So very beautifully, you'll be able to see, you can perform what if analysis on this. So that's the sort of a connect that is possible. That's one thing. And now if you see here, your distribution tab. And as I did, so how each of your assets is performed, all of that can be done. And again, by just using your thumb and then pressing on a field called as portfolio distribution. So that's what you get to see. I'm just in the interest of time moving ahead. And I also wanted to show you this. Hands and touch this virtual button, you're personalized. So here is a personalized advisory, and this is where AI would come in, video that combined with AI. So it takes care of all where I have invested, it provides the information, and it says what I need to do. Hold on your real estate investments and what more you need to do. All of this is quite possible through an augmented reality. And just to close this, I just wanted to, interest of time. Now, here is another possibility where it's, how many times have you read the brochures of your wealth company? Somebody comes and says, without any names on a common forum, that I have given you this offer, this product, why don't you pick up? Do we really care? We are busy with our own stuff, but look at the way even the company can connect. They can, you click on it about our products and a beautiful video with just soothing music, you'll be able to understand what this company has to offer. Yeah, so that's that's pretty much what I wanted to show you in terms of how multiple technologies can come together. And it's just not here, even in universities, and we are doing it. Many of the organizations are looking at it, and I'm just going to show you how each of you can create your own digital twin and make it speak. For example, today, I do not know the names of any of your LPU professors. If you missed a session by him or her, you can have the piece of content, lip sync it, and you can have the digital avatar of that character come and talk. Like this is another sample. If you see using augmented reality, I have tried it at my home. This is me.
Hi, welcome. This is Sita here. I am a proud Nomura employee. I work out of our Powai office, which is in Mumbai. Nomura is a global financial services group with an integrated network spanning over 30 countries and regions. By connecting markets east and west, we service the needs of individuals, institutions, corporates, and governments through our three business divisions: retail, investment management, and wholesale, which includes global markets and investment banking. Driven by the insights and innovation of some 26,000 people worldwide, we put our clients at the center of everything we do, delivering unparalleled access to, from, and within Asia. To know more about us, Nomura, visit www.nomura.com. Thank you.
All right. So that's the power of what multiple technologies, including the augmented reality that you saw, could do. I'll just quickly take maybe 2 minutes, Mr. Ajay, just to close out, if that's okay. Just have a few more slides.
Yeah, that's okay, sir.
Okay, thank you so much. I'm conscious of the next speaker coming in as well. So I think the message is, while I'm anyway going to share this PPT or PDF version, folks, this is the time. We are at the best of the times in terms of looking at how technology is revolutionizing. And there are challenges which are very much there. Huge amount of research opportunities. I have listed it down. I mean, my daughter is doing her bioinformatics. We speak a lot about some of these aspects. How do we do genomic sequencing? I mean, at the stage that she's in, it's too early, but there's so much of revolution possible, so much of new discoveries possible in research in these areas. Genomic revolution is one, drug discovery is another. I did show you some slides about in the first session again on climate and earth sciences. This is another area, largely factoring in the sustainable part. How do we protect Mother Earth? Build the best climate modeling with the combination of high performance computing and AI. So that's another area of research that you could look at. Material science, completely new area for me. I have not much of an work experience on that, but I could say that when I read any article, this does come about as one of those promising research areas on solar cells, digital twins we just spoke about just some time back. Financial technology area that I belong, high frequency trading or HFT, risk assessment, identifying frauds just at real time at the point where it happens. We know about point of sale solutions, right? At the point when it happens, you instantly get to know. So that's another area of research that we could look at. And then economic modeling, we just had our budget today. I didn't get a chance to see what the impact is, but looking at all the pros and cons of what I have, this number, that number, all of that combination from a building an economic model perspective to ensure that we have a sustainable policy impact. Network effects is something that can be another area of research. Just to end, last couple of slides from my side. Industry trends we already saw. We've been through, you all been through the 6 days, I believe, including today of your training. This job market is evolving completely in a different way. Every day, very interesting roles are being created. All I would say is this, and we spoke about many concepts, frameworks, language, software, hardware. Today we saw about completely a different avatar of augmented reality, virtual reality. We spoke about quantum processors, neuromorphic computing, photon processors, photonic processors, all of that. This is just a gist of areas. Continue to keep reading. These areas will help you to build the skills. Continuous learning is the only key for success. So with that, I would like to end my session. I'm sorry, I've just taken it so close to the next session, but I just got myself into it, sir.
Still, we can steal some time from the next speaker and have questions if somebody wants to ask. Any question? Please put your questions on the chat if you want, or you can say, you can speak also. That's the fun of online classes, that you don't know what other person is thinking about. Yeah, are there some questions? Then we can carry on, because it was an excellent session, sir. A lot of things to learn, especially we are working on AI. Sometimes we make fun also. And I'll just ask you one question from my side. Like many a times we see Honorable Narayan Murthy speaking about something on his one project of that's investment of money getting double, triple kind of thing. We see one project of investment. And I think that is created, that is a deep fake created on his image, because he never does something like what is shown on the social media platform, as far as I have read about him.
True, sir. That is true. What to believe, what not to is becoming very difficult these days. I'm bound from talking about industry experts based upon the compliance and legal that I come from, but from my company. But generally speaking, we should be very careful. Even political campaigns that are happening, with what you just saw, right? And anybody can spoof. We don't know who's saying. Even the lip sync can be so realistically created, sir. So I think that's where we need to be very careful about the fallouts of these technologies. But having said that, put to good use. In fact, recently I had done something for deaf and hard of hearing people. They use sign language. How do we instantly allow them to use the sign language, and with generative AI and computer vision, how do they actively participate in any field, be it a HR induction program or be it in a railway station, you have a kiosk. They just wanted to know about when is this train going to come. Announcement that are getting made, they don't know, right? I mean, how do they get to know about that? Of course, they can chat, I understand, but sign language is ages together we have been practicing sign language. It's like our Hindi, Sanskrit, and other languages that we have. So why do they need to miss out on that? So social good for AI is another very good area of research that some of the scholars can really look at, sir.
That's great, sir. Thank you very much for such insightful session to all of
Okay.
us. And I invite you for the validity session, 6:30. You have received a mail, I think so, from us.
I will have a look at it, sir. I will have a look at it. And
It's,
make my
I'm
assessment.
sorry, it is on at 7:30. So
Oh,
please
okay.
look at it and grace us with your presence.
Sure. Definitely, Mr. Ajay. So thank you so much, folks. I hope you had found all of this invigorating and giving you some options to search. Nobody can become a specialist in an area, and if you have an interest, of course, you can deep dive, do your PhDs. But it's a great opportunity, great era for all of us to live, where technology is flourishing a lot. With that, let me say goodbye to all of you. Thank you so much for your time, and I will join the validatory function, Mr. Ajay ji. Thank you so much, everybody. Thank you, sir. Thank you.
This is the session, last session. After that, there will be a test. Test will be on Google form. And as ATAL director, we have to put marks of your tests. Now, one more thing I'm getting from some people that they have attended and their attendance is marked absent. One thing is there, if your attendance is there in the Google form, we have made it sure that it is marked present, but if we have missed, we will check. Finally, there is a option of editing attendance, but for those who are really present, so we'll go on through recording. So we have taken the chat and participants record also, so we will definitely go for that. Second thing is, today also have given you the attendance link. So again, we are putting it on. So we will keep on putting it on, and we take only one attendance on one day for making it simple for you. And we keep on putting it on. And now the next speaker will speak, and we have to wait for maybe 5 odd minutes to start the next session. Please don't go anywhere. In the meantime, can I see Mani Arora, sir? If you are there, Mani, sir?
Yes, sir.
Mani,
Yes, sir.
are you
Sir, I'm
there?
here, sir.
Can you see?
Currently, sir, I don't have webcam attached to my workstation, and as
Can you speak something about
yes, sir.
yesterday's session? Yesterday's session of Mr. Nanda, Dr. Nanda.
Yes, sir. Definitely, sir. Good evening to all. So yesterday we had learned the file system behind the working behind the high performance computing, and so far we have learned the two aspects. First, the computing scenarios, multi-programming scenarios, multi-programming architectures, and the second aspect is the storage processing. And yesterday we had learned two file systems as taught by the Sanchit sir. First is the Luster, and the second one is the HPFS. Luster is the type of parallel programming distributed file system, the word which has been derived from Linux plus cluster that make the Luster. It is a storage architecture for the clusters and central to the Luster file system, best known for powering the high performance computing. And that includes 10,000s of client systems and petabytes of storage, gigabytes of speeds. These are the common components of these Luster architecture, and the scalability to add more and more and more servers in the Luster. And the main components in the Luster file system, there is a management servers, management targets, metadata servers, metadata targets, object storage servers. Luster clients compared to these servers through the connected to these servers through the Ethernet, and the Ethernet has evolved to the greater level, which is called the InfiniBand, to connect these servers and storage connectivity. There is a data stripping and the RAID levels, RAID 0 level, RAID 10 level, and that divides the data into chunks of data in a file to be stored on different OSTs and object storage targets. And the second one is HPFS, which was developed by the IBM for its OS2 operating system for the high-end servers, and which is designed to handle large files and volumes over the older file allocation table. And the key takeaways that we had discussed yesterday by the Sanchit sir, the increased speed and efficiency, improved data integrity. The data integrations means while we just save the data and from the transferring of the data, it will decrease the data usage between these two terms, saving of data and transfer of data. The efficient management and the organization of large amounts of data on a disk. HPFS supports long file names up to 254 characters as compared to the older FAT architecture or the file allocation table. And so this is a very huge concept and required so much practice to get such kind of expertise that we had witnessed yesterday by the Sanchit sir. So this is all from my side. And thank you, Ajay sir. Thank you, LPU HRDC, for giving me such opportunity to speak here on this platform. Thank you very much, sir.
A big round of applause to you, sir. Actually, I was telling him to do this and he was a little busy, but
Thank
he
you, sir.
really observed the session and think went through the recording very properly. That's great, sir. And I wish everyone might have heard it. So let's have a thumbs up for him. Now we have another speaker online.
Somebody can just tell me if my voice is all right. So I'll start on the second part.
Yeah.
So this is almost visible. Is the screen visible? Can somebody just unmute and say yes?
Yes, sir, your screen is visible.
So today we'll be talking about CUDA, programming and optimization. So the session was originally being taken from Mr. Gagan Sharma, who's the CEO of a company. But due to some unfortunate last-minute commitments, he's actually right now in US for some very important clinical trials. But he has left out a short video recording. So I'll be playing out that first. And as Gagan keeps mentioning, sky is the limit. Currently, he is in the sky. So let me just start off his video.
Aditya, we cannot hear.
Oh, I'm sorry. Just give me a minute. Can somebody just help me out over here? Oh, cool. If the sound's visible, just let
Good
me know.
evening to everyone, and thanks for this invitation. My name is Gagan Sharma, and I was given the task to present this topic to all of you, but I was summoned to Los Angeles today, and I'm flying out in the afternoon as per the Melbourne time. So while you will be listening to the slides, which I'm recording right now, I will be in the air, but the remaining part of my work will be presented by my colleague at Proxmed, which the company I lead, by my colleague called Aditya Chaturvedi. Sorry, Aditya Chaturvedi. Well, Aditya, name is just a variable. It's the way you address each other. So thanks for the invitation, and let's get started. Let me share my slides. A little bit about myself. As I always say, I'm a lifelong student. Until the age of 30, I wasn't sure what I was doing. But one day I was walking next to the Yarra River in Melbourne with my colleague, whose name is Soren Christensen. I call him my mentor. He was saying that, Gagan, there is a job for everyone. You have to find it out. And I didn't understood at that time. So, job for everyone, what do you mean? But a couple of years later, when my focus becomes very clear in the world of stroke and the imaging, I felt what he said on that day. When you are into something, you're on a mission, you enjoy what you're doing, then daytime, days of the week or month of the year, doesn't matter, right? And you really feel limitless. However, we follow strictly to challenge the status quo. By that, I mean that I have to challenge myself. So we have to be the better version of ourselves every day. All of you know that I am a little bit old. I went to university in 2002, which I'm very proud of, while doing the MCA, because that's the alma mater. That's where I actually started. But I'm also very thankful to a place called AICTE in France, which is a very, very reputed institute. It's in the west of France, in the region called Breton. But when I was in Melbourne, I decided to do a project management and combined business administration degree in IT. What I do for a living, I think as I said, I enjoy, but I have to bring the food on the table. So commercially, professionally, and academically, I work in a domain called the image processing clinical trials, where we are very much focused in creating the solutions in such a way that they become the helping hand for decision making for clinicians in a devastating disease which we call which is stroke. And these tools helps our clinicians to take decisions in the spur of the moment, because as you know, stroke is a very devastating disease. God forbid any of us or anyone in the world ever goes through it. However, by saying that it's not going to go away, we have to take precautions, but also if it is happening, we need to have tools which can really help the patients for a better outcome. Again, I know I have said many words, but I will reiterate that we are creating the tools, or we are trying to create the tools which can really, really help our clinicians for a very, very good patient outcome. And that's where we feel empowered. Now, my journey really started in 2011 when I started working in the world of stroke, and I was selected as the research intern. And I was blessed to be trained by the best in the industry. And I'm not just saying it to impress all of you. I was really blessed. I was lucky. And I've worked a little bit hard also. Over the years, I'm running many verticals, including the research at the University of Melbourne, the University of New South Wales, and also we have incubated our company called Proxmed. We have many verticals, but the verticals which are very close to my heart is the image processing, clinical trials, because as I said, I was blessed, privileged, empowered over the years. But when I started in this domain, I learned so many things that they really helped me to deliver my data management duties in a very, very pivotal trials, which are really creating a paradigm shift in such a way that the care for the patient is improving every day. However, having said so, doesn't mean that there is still no room for the improvement. Sky is always the limit. But my work, which we have got published, it's the testimony of the hard work we as a team, led by many clinicians, in this field, as it was published in a New England Journal of Medicine, which some of you may know that it's the highest impact journal in medicine, Lancet Neurology, JAMA, JAHA, Stroke, and many others. As I said that I was lucky, excuse the typo, that I was trained by the best in the world. Now I can go in the CUDA management, which is the topic here, but I will explain that via Aditya as we move forward. However, I want to bring this particular example into the focus. The reason why, because this is something a cutting edge. I am working with my team to create a solution in the AI/image processing domain. As I said, stroke is a very devastating disease, and there are many ways. However, being in India, and I have traveled in the last 2 years extensively to many Indian hospitals in north, south, east, west, and I can say very confidently that in spite of having 1.6 million stroke prevalence in India, the awareness on the ground in the tier 2, tier 3, tier 4, and villages kind of a cities is still low. As we all know that what heart attack is for the heart, stroke is for the brain, but the myocardial infarction and the infarction and the treatment is quite strong. There is a well-laid standard operating procedures workflow almost in every nook and corner of India where the medical facilities are available. However, in terms of stroke, we still have to improve a lot. And that brings me why I'm showing you this picture. As you know, in India, all we do is basically we have to go to hospitals, but most of the times when we go to the private systems, we have to pay from our pocket. And you can understand that stroke is a devastating disease and the treatment is very costly, because only the contrast which is given in the developed economies to do the CT perfusion or MR perfusion by gadolinium, that's a contrast agent. Excuse me. It costs patient a lot, and the cost can go from in Indian context from 2 lakhs to 20 lakh Indian rupees because of the complications involved, and hence the choice of the modality to scan the patient in such a way that we can get the maximum info out with the minimum possible cost is something we always are very mindful, and our solutions revolve around this kind of a strategy. And non-contrast is one of a modality which is not only done in India, Nepal, Bangladesh, Pakistan, all other these emerging or underdeveloped economies. but it is also the modality of choice in the developed world where a patient is scanned when this devastating devastating disease falls. So as you're seeing on the screen, there is a red color, and then there is one slice of the brain. You can see the red region, which is marked. That is marked by our software called the hyperdensity software, and it tells you that which areas in the brain are basically hypertense, where the signals have reduced quite a bit. Now, why I'm just showing you this statement, because eventually when Aditya will be presenting the CUDA work, I want to bring this example into it, how when we were working on this particular project in the artificial intelligence, deep learning domain, how CUDA, management of CUDA, applying the CUDA strategies so that our algorithm can really process at a great speed the data and gives us the outcome as soon as possible, because as we all know, time is brain. Now, why the CUDA management becomes important? Because when you're working in NVIDIA, it is proprietary framework, and you all want to do is that, okay, you want to train your algorithm so fast that when you apply or implement your algorithm in a real time in the hospitals, you can even use the power of CPU and the low-end computers. GPUs are not cheap, and these days it's really costly. And as I said, Aditya will speak a bit more on my behalf as we move forward. Now, choice between the CUDA and the open source alternatives often depends upon several factors, including the performance, ease of use, community support, extra. I remember this community support word, which I just uttered, is very important, because I started using Linux when it was not that developed since 1999 when I went to my master's, and from there onwards I read many stories, and just for fun and to raise your curiosity, I have met Linus Torvald. I'm sure you know that. He's the father of the modern Linux. Richard Stallman was the other guy who wrote who has contributed a lot. I don't want to discuss this at this stage because I met both. On the other hand, I have also met the Red Hat folks in Auckland. So very interesting stories that may be for some other day. But coming back to what I was saying, that CUDA is a NVIDIA's proprietary framework, and then there is many other alternatives such as OpenCL, ROCm, SYCL, extra. Just out of curiosity, before I hand over my talk to Aditya to present the rest of the work, what I really want to say is that I have met many people in India, especially in Bengaluru. There is a guy called Sasank Chilamkurthi who has been trying to write or challenge this CUDA framework from the open source perspective. Again, a very good friend of mine and the founder of two companies, a very young guy from IIT Mumbai, IIT Powai. And things are changing. There is more challenges coming to CUDA. However, let's bring and steer back the conversation to the CUDA and the memory management. And I will let Aditya present the remaining work. However, I definitely want to say this, that it's an honor to talk to all of you and present our work, not only from the conceptual perspective, but also with a real life example. And I wish you can take some of our learnings with you and apply that, but we are always here. If you need, you can reach out to us via our email address, which may be the LPU, where I have worked from 2004 to 2007, 2005 to 2007, and we can discuss this offline when it's needed. But again, it's a pleasure. So I let Aditya take over from here. So thank you.
So let me continue from where Gagan left, and we'll be talking about CUDA. So before I begin my session with CUDA, just a short introduction about the workflow of the session. So currently, I did not have a good idea about what sort of audience I'm catering to. So I've tried to make this presentation as a mix of an introductory perspective towards CUDA, also towards a little more deep dive into optimizations, memory optimizations, and also in terms of the architectures. So let's start. And also, I would appreciate if this session can be a little interactive. So you're free to interject me at any point of time, but in the interest of time, I would request that if you have some really important question, just feel free to unmute yourself and ask it. I'll be happy to answer. And in the end, I obviously will be having a question answer session. So let me start with CUDA. So CUDA is NVIDIA's proprietary parallel computing based platform where you can utilize your GPU for computing purposes, or to be exact, general purpose computing purposes. Now, for CUDA, I'll be more focused towards C because that's my core competency. CUDA is also very much available in C++. CUDA is also there in Python, but since C and C++ are much more low-level programming languages, so this is where we'll be focusing on. So in this session, what are you going to learn about CUDA? So we'll be learning through, I've actually added a few programs so that not just you learn through the theoretical sides of CUDA, but also through some programming side. So let's start. And for the prerequisites, I'll be expecting that most of us would be at least somewhat proficient in C or C++. And if you want to try whatever small examples that I show, you're free to try, but you would require some sort of NVIDIA GPU, even though if it's very small. And for sure, you'll not be requiring any sort of parallel programming experience, and neither do you need a graphics experience. So let's start with Hello World. I think most of us have seen this cliche program that we do. We start off any of our programming languages with Hello World. So we'll be starting our CUDA-based parallel programming with Hello World. But before that, there's some terminology that I would like to discuss. So in this session, whenever I'll refer host, so host would be referred to as the CPU and its memory or the surrounding memory. And whenever I refer to as device, that I'm generally referring to the GPU and its memory. So just to make that clear. And as you see, heterogeneous computing. So this is just another word for parallel computing, distributed computing, whatever you call it. So just a simple workflow in how you apply your GPU for computing purposes. So generally in CUDA, the workflow is like where you copy your input data from CPU to GPU, and then you load your code and execute it either via caching data, or you can directly use the global memory. It's up to you. Depends on what sort of task you have in your mind. And finally, once that execution has taken place, you copy that result back from GPU to the CPU memory. And we'll also be talking about a bit about PCI bus, a bit of their architecture, although we're not going very deep because I have no information regards to what sort of audience I'm dealing with. But I've tried to make it balanced from both perspectives. So somebody who has totally no experience can also learn, and somebody who knows about the basic stuff can probably learn from a deeper dive that we do a little later in this. So this is one of the most common programs that we do, which is a Hello World. This is a snippet from a C program. And just to let you know, so we'll be using two compilers over here, one from NVIDIA's NVCC, and the other would be a normal GCC compiler for C. Now, the standard C compiler that you would use would probably run on host. And as I mentioned, host means the CPU. But the NBCC or the NVIDIA compiler can only be used with the device that you have, which means the GPU. Now, how do you actually execute the program on GPU? So we use, just to also let you know, CUDA is exactly C. You can consider CUDA as exactly C with certain extensions. So what happens is with CUDA, you actually have those extensions giving you an interface to the GPU. And one of those interfaces is this global keyword that you probably add in before your normal void method to just let it know that this would be going into the global memory of the GPU. So currently we'll be talking about more a little later in the presentation. So this global keyword actually indicates that it's a function and it is letting you to interact with the DRAM cache of the GPU. Now, how does NVCC or the NVIDIA compiler operate is, it would create a sort of intersection, or you can call it a separation between the source code on your CPU and the device components. So let's talk about how we're going to do. Just a minute. Yeah. So we'll be talking about kernels. So kernel is just nothing but a program that you launch. So whenever in the following part of the presentation, I mentioned about kernel. Kernel is just something that a program that you're launching into the GPU. So this is one basic program. So what we have done is we're telling that there's into the GPU global memory, we're creating this particular function to be executed over there. And then in our main function, we first initialize this kernel, and I'll tell on later what this 1,1 means. And then we say that print hello world and return 0. Now, if you look at the output for this particular code, you'll see it's just a hello world. So why was it this there, right? Somewhat like didn't do anything, right? So we'll talk about this a little later, but why are we interested in GPU-based computing? So the GPU-based computing gives you the it gives you the resource of doing massive parallelization if you were to compare it with CPU. So the main big difference between CPU and a GPU is GPU can give you the power of computing in massive parallelized form, which CPU cannot. So let's start with a basic program for doing additions. So in a normal C program, what you would do is probably either in your main function, you would have your 2 or 3 variables, and basis that you would just add in either an input, or you would rather program it to have certain values added together, or the other approach would be to just have another add function that takes in certain parameters, and then you add it and then return it. Now, if you were to do this addition, let's say on CUDA or on your GPU, now we're talking about this program in a very basic format. So this is something that might not be very useful, but this is very useful in understanding how the actual GPU-based parallelization happens. So if we, once I've told that since you add this global keyword before your void function, so what this does is it will, as I told, would create a space in your GPU DRAM or the global memory on the GPU. And after this, in your main function, if you call this particular void add function, what will happen is the add will execute on the device, which means your GPU, and then will be called from the host, meaning the CPU. So Also to note, we are using pointers over here because it needs to point to a certain location in the GPU memory. Now, let's talk about a bit of memory management. So the device pointers always point to the GPU memory address. It may be passed to and from the host and may be dereferenced or referenced from the host code itself. Now, the host pointer should always point to the CPU memory. It may be passed to the device or may be taken from the device. And just to give you a basic example of the CUDA API for handling device memory. So if you remember if you were programming in C, one of your basic equivalents for allocation of memory would be malloc. If you want to free the memory, you'll probably use the free or memcopy for copying the memory. If you're doing this for CUDA, what will happen is we'll have a CUDA malloc, CUDA free, and CUDA memcopy. All of this are actual equivalents for malloc, free, and memcopy. Now, coming back to our add kernel over here. Now, let's look into the main function. So we have defined 3 variables, A, B, and C. And we'll also be defining 3 variables for the device itself. So the device should also have these 3 variables, which we are calling at DA, DB, and DC, just to ensure that we don't get confused. So this is a pointer referring to A variable in device. This is a pointer referring to the B variable, and this is the pointer referring to the C variable. And we define size into just the integer size of int. And then we're going to allocate the space for A, B, and C on the device. So we'll use CUDA malloc to allocate memory for A, B, and C with their particular size, in this case being an integer. And then we'll set up 2 values, 2 and 7, and copy these values from A to the CUDA memory. And same goes for B to the B variable in the device using this particular function. So this is CUDA memcopy host to device. So when you use this function, what it does is it will just create a clone of the value, whatever you're entering from your this variable to this variable in the device. Now, before this, we have already defined our values. We have created our the equivalents in the GPU. We have pointed their values itself. Now the only thing is to launch the function. So whenever we're going to launch a function on the GPU or launch a kernel on the GPU, we're going to use that same function that we defined over here, which is add. And since it was in GPU, so we're going to add a block size and a grid size. And in that would be using these 3 parameters, since the particular function expects 3 parameters to be there. And once all of that is there, we're going to, so once you execute this particular part, your GPU will start executing the following program basis on this function that you created. And once this is done, we want to copy those values back from the GPU to the CPU. So since we're storing this in C variable, as you can see, we're saying that C is A plus B. So in this case, we just want to copy the value from the GPU C variable to the C variable in the CPU. Using a similar command where CUDA memcopy, instead of host to device, now we'll be doing a device to host. And once we've got our values back, we want to clean the memory as well. So we're just going to free the memory using CUDA free for A, B, and C because we created 3 particular values. Now, let's talk a bit about GPU architecture. So before I delve into this GPU architecture, I'd like to also mention that whatever values, specific functions that I'll be talking about will be based on NVIDIA's Fermi architecture. So Fermi is a very old architecture about about a decade old architecture. So currently the architectures that NVIDIA is using is beyond Turing, Volta, and Ampere. I think Ampere is the second latest one. But just to let you know why we are going to deal with Fermi is, this is the Fermi multiprocessor diagram. Now, since we're talking about a decade old, so it's much more easier in terms of understanding it. If I were to take you about 5 years back into an architecture which might be much more towards the real world GPUs, I'm going to show you another architecture over here. So just give me a moment. So if I were to give you an idea about let's say we talk about, instead of Fermi, we're going to talk about Turing. So this Turing microprocessor or the architecture is about 5 or 6 versions ahead and looks somewhat like this. Give me a minute. So if you look at it in detail, it will be very difficult to actually grasp CUDA using this particular architecture. Yeah, so you can see the difference between Turing and Fermi architecture. Now this is much more advanced architecture. And just to give the numbers in this case, so we're talking about 1500 CUDA cores for this Turing architecture versus about 32 or 64 cores for the Fermi architecture. So we'll be referencing this for our CUDA talk because this is much more easier to talk about. And this is a bit more scaled up version with a bit more changes into the way it's handling its cache and other things. So let's talk about a few things before we move ahead. So in software or a CPU terms, there's something called as a thread. So threads are generally processed by scalar processors. In GPU, we have a CUDA core. And a CUDA core can have multiples of thread blocks. And similarly, those multiples of thread blocks together can form a grid. And in that particular way, multiples of grid are present in your GPU, which can be utilized, which is why we massively, which is why we say that generally GPUs are used for massively parallelization tasks. So this is just some numbers from the Fermi architecture. So in this particular architecture, the blocks divide the groups of 32 VOPs. VOPs are basically normal scheduling units, and context switching is free in this case. And in terms of latency, VOPs generally tend to hide latency. In terms of, yeah, you can call it executional latency or memory latency, almost similar. And VOPs generally perform in SIMD-based architecture, which is single instruction, multiple threads. So single instruction, multiple threads, you can think of it as in SIMD, but it's a little different in terms of the way NVIDIA has defined it. So let's talk about the memory hierarchy in this case. So we have registers, we have cache. In cache, you can have shared memory, L1 cache, L2 cache. There's something called as a context memory that we'll also talk about a little later, and global memory. Now, this is the hierarchy of the Fermi architecture that you're seeing over here. Now, each register has its L1 cache over here and its shared memory. And all these registers are in multiples of streaming multiprocessors. SM stands for streaming multiprocessors. And this grid of streaming multiprocessors together is connected to an L2 cache, and that particular L2 cache is connected to your global memory. And just to make it a little less complicated, whenever I say global memory, just think of this as your DRAM memory in the GPU. Now, how do we run in parallel? So there are multiple ways of moving to parallel. You can utilize blocks. So when I say blocks, blocks are generally multiples of threads combined together. So as GPU computing is mostly about massive parallelization. So how do we actually run this code parallelly in this device? Let's talk about that. So we'll be using that same particular add function, but in this case, now that we are running it in multiple parallel processes, so each parallel invocation of add would be referred to as a block in this case, and a set of blocks would be referred to as a grid. Now, each time when you invoke it, you can because multiples of blocks together form grid, so you'll have an index for each block. And so we'll be, since in this case, we are parallelizing it based on blocks, so we'll be referencing it with the block index of X, and then same goes for A and B. And this particular index is necessary because we're talking about contiguous memory in this particular case. And on the device now, each time when you're, let's say you defined it for 4 blocks, so this particular thing will run with 4 blocks and it will produce 4 different outputs, or 4 same outputs based on what function do you put in over here. And now this is a vector addition problem that we are seeing over here. This is a basic vector addition function. So we've defined as simple A, B, and C that you saw in the previous example. And similarly, you'll have to define A, B, and C for the device. Now, here we are going to use integer precision for this particular case. And once we've defined all of this, we're going to again use that CUDA malloc to allocate space in the memory for our 3 variables. And once all of that is done, then we'll have to allocate the space for the host copies of ABC. So A would be the integer times the integer of malloc of size. You can use random integers, whatever you like. And once that is done, and you're going to copy the value from A to the variable A in the GPU memory using CUDA memcopy host to device. Same goes for B. And then you're going to launch your kernel. Now, since we are using for multiple blocks, in this case, if you're defining it for n blocks, so we're going to have n blocks in one grid. And once we have defined this particular thing, we're going to give its parameters which it expects. So add is a function that expects 3 parameters, A, B, and C, which are given over here. Once this line executes, you already have your values. All you need to do is just copy the result from the GPU back to your CPU, and that is done. And always remember to free up your space. That is done. Now, the difference between host and device in this particular case, while we are just doing a simple addition, which might not seem a very relevant example for parallelization, but this might help you understand how we actually do it. Now, let's get back to threads. So each block, as I said, is consisting of multiple threads together. So currently what you just saw over here was an example of parallelizing via blocks, we can parallelize via threads as well. So let's change a bit of the function over here. So instead of using blocks, we can use threads. Now, since there are multiples of threads involved over here, so we'll have a thread index as well. So you can reference it with your C of thread index. Same goes for A and B. It's just similar thing. So in the previous program, we were using block index. In this case, we'll be using thread index. And this is just the basic implementation of vector addition and using threads in this particular case. And how much time do we have? Cool. So combining blocks with threads. So since you already know, the GPU contains multiples of grids. Each grid has its own multiples of blocks, and each block has multiples of threads. Now, it's up to you how you utilize based on what sort of task that you're doing. Generally, in cases of, so let's talk about how the memory actually gets allocated in. So in this particular case, if you look, this is your thread index 0, because this is the first thread. The second thread holds this value, third this, fourth this. Now, let's take another example. Okay, so before we move to that example, let me just finish off with threads. So threads generally seem unnecessary, right? Why to add too much of complexity? But remember, when we talk about massive parallelization, we're not talking for simply addition or multiplication thing. Think about it in respect to people who are doing research in computational fluid dynamics. I'm sure somebody might be here from that. So in CFD, you're probably dealing with higher order differential equations. Let's talk about, I'm a machine learning engineer at Proximate. So I deal with a lot of deep learning based tasks. And what's the most important part in deep learning? That is linear algebra, right? You do all sorts of matrix multiplications. Now, let's talk about, I deal with a lot of computer vision based tasks where like Gagan mentioned about hyperdensity detection. So we are having a very high quality CT image, which itself has multiples of slices. Now, image itself is represented into a big chunk of matrix. Now, for training it, you're doing it millions of times, multiple matrix transformations, multiplications. Now, if your whole size is so big in training, it will have problems. So how do you actually solve those problems? This is where CUDA comes in. So this just to give you an idea why we have so much of complexity in this case. And now let's move about memory optimization. So if the code is memory bound and effective memory throughput is much lower than the peak, so this is where we'll be dealing with a lot of optimization techniques. So one such technique over here would be coalescing. So is anybody familiar with coalescing? So just to give you a short idea about coalescing, so when you allocate a memory, let's say, let's talk a little bit simpler terms. So you're doing some sort of operation in the GPU, and your threads are accessing memory in a contiguous fashion. Contiguous meaning they're consecutive in the index values. Now, if they're concurrently accessing a lot of those, and each call would be expensive in terms of execution time. So coalescing is basically you do a transaction where you combine all of those contiguous locations into one so that the memory access time is much less. You can think of it as some form of an L1 cache. Now, so let's talk about shared memory. So before I go into shared memory, something about the basic memory definitions in GPUs. So you can have multiple. So there's one memory which is called as global memory. The other is called as a shared memory, and there's another memory called as register-based memory. So in the constant memories. Now, in terms of the hierarchy, the global memory would be in the lower chains. As you go down, you'll have shared memory. Shared memory is shared between the threads between the threads and used for communication between each of the threads. And let's come over here. So we'll be applying a stencil operation. So in this particular stencil operation, what we're going to do, a basic stencil operation is, if you have a defined radius of R and you have elements in a memory like this, so you're going to add, you take a sum between both those two. So let's say you have a radius 3. So what you're going to do is you can take 3 elements from anywhere here and 3 consecutive elements afterwards. You can add it and would be the sum over here. This is a basic stencil operation that we do. So why not just to also give you some values. So the throughput of shared memory is much, much higher compared to the global memory. Why? Because if you look into the GPU, there's a chip and the DRAM surrounds the chip. So shared memory is also sometimes called as in-chip memory. So because it's inbuilt into the chip, it's much more faster. So in terms for Fermi architecture-based GPUs, your throughput is 73.6 gigabytes per second, which might seem very less, because in today's GPUs, you're talking about in multiples of terabytes per second per streaming multiprocessor. But since we're talking about Fermi microprocessors in this Fermi architecture in this particular case, so this is 73.6. And so sharing data between threads. So shared memory, because it's an in-chip memory, we also need to be very careful about is the shared memory is very small. It cannot be very large. It's in-chip and it has to be used judicially. Now, why are we talking about shared memories is because the way we handle our operation where we are storing our data, that actually that will give a lasting impact in terms of how fast your execution speed is. So if everything is stored on the global memory and you're using those particular global memory to execute, it will be much, much slower. Instead, you can approach the shared memory, but problem with shared memory is it's very small. So there's some caveats into, you have to use it in innovative ways. We'll be looking at it somewhere later. And so we have a bit of time. So let's talk about this particular function. And so we have something called as sync threads. What sync threads does is it synchronizes all threads within a block. And why we are talking about sync threads is, I'm sure if people who have done basic multiprocessing via CPUs, if you access multiple, if you're parallelizing your processes and you're accessing the same location through multiple processes, you come into race conflicts, right? Similar kind of conflicts can occur over here, which is why we use sync threads. And just to give you a basic review, we'll be looking into some, just give me a minute. Okay. So we're talking about, so this was all basic GPU architecture. Now, let me just show you some basic programs. So since we deal with AI and let's talk about a basic matrix multiplication program, right? So if you look over here, we're defining so this is a basic matrix vector multiplication. So we're saying that we're having a square matrix, we're multiplying it with the flat vector, and whatever vector that we get as the product, we'll save it. Now, the basic C program is, let's say we define the size of matrix as 1024. And we're going to, just for the simple initialization, we're going to just use the index values to define the values. And this is your basic matrix multiplication formula. You do I, J, and K, and then you just take one row and multiply with the column of the other, save it, and that would be your first value over here. Now, you could say that this is a very naive approach to do matrix multiplication. There are much more optimized way. But I'm just going to show you what difference it creates if we use GPU in this particular case. But this is a simple C program. So let's do one thing. Let's increase the size of the matrix because this is very small. I don't think so any practical machine learning task will use such smaller matrices. Let's use this big. This should be fine. And so let's compile it, and then let's see what's the time for running this. So let's compile this. So yeah, we'll call it matmul-C. Oh, just give me a minute. Did we do something stupid? Okay. I think this should be the matmul-C. Just a minute, sorry guys. In function init matrix integer overflow. Okay, got it. Let's reduce it a bit. Let's keep it here. This should be fine. Yeah, so this compiled, and let's just run this. So matmul-C, and let's we'll look at the time as well. So it's still computing, right? So it's still computing the value, and yeah, we got the value from the top left 2x2 matrix, and let's see the time that it took. So matrix matmul-C. Yeah, so you see it takes around 10.59 seconds for the CPU to compute this. Now, this can vary a bit. Let's see. So it would be generally in this particular range because the CPU is busy doing a lot of other tasks as well. So this value might change, but let's look at a CUDA-based approach. So over here, this is your same function. We haven't really changed the whole way of calculating the matrix. But in this particular case, what you're going to do is we're going to assign this particular function in the global memory space. And we're going to have a row and column. And that row and column would be the size. So the row would be the size of the block ID of XY. So it's just the same as over here. So if you see, we're doing n cross n plus the size of the float because we're using floating point over here. Just so this is, you can think of this as n cross n plus the size of the float. And you do that same. So basically, what we are doing is, if we have a big, let's say, 10 cross 10 matrix, you're taking a smaller submatrix over here and using it to calculate the other value. And then you are just doing it into loop with multiple threads. And this is the exact same way that we do. We have the host variables, A, B, and C. we have device variables A, B, and C. We're just using H underscore and D underscore to distinguish. Now we're going to allocate memory in this case. So because we're doing a matmul operation, so we're using a floating point in this case. So we do the floating, we allocate the host memory, and we initialize the values for the host variables. And then you're going to do the same for the device memory as well. You need to allocate the memory in the device itself. And once it has been done, all you need to do is just copy these values back into the device memory. So you're doing a CUDA mem copy, which is very similar to C, the mem copy in C or C++. So you copy the values of A in host to the variable A in the device, and same for B. And you're going to define the threads per block. So currently, if you see, we've defined the block size as 16, so using a 16 block size. And we're going to set the value for blocks per grid. Once you've done that, you're going to launch the kernel, set the value for blocks per grid and the threads per block. And you're going to give in the parameters for the function. So matrix multiply has 3 parameters, you give in that. And just to make the results not too bad, because it's a very big matrix. So we're just going to look at the top left 2x2 corner. And once we've done that, we're going to just free up the memory space. And just for the purposes, you can see we are just setting 1024 as the size. Now let's compile this and look at the output. So we compile this matrix CUDA basic, and so, oh, sorry. So because this is a CUDA operation, so we can't use GCC, we'll be using NVCC. I'm really sorry for the stupid mistake. So we just call it CUDA basic, and see, it's compiled. All we need to do is now just run that. So CUDA basic, and you can see it's quite fast, right? The earlier it was taking some time to present the output. It's very fast. Let's look at the time. So the time for this to compute was 0.36 seconds. And if you were to compare it with the time used over here was 10 seconds. So you can actually see the difference in this particular case. Now, this is not a very optimized approach either. This is just the basic implementation of what we did in C into GPU with utilizing its multiple blocks. Now, remember I talked about shared memory as well. So you can actually utilize shared memory as well in this case. I'll be giving out links because we don't have a lot of time. I wanted to talk a lot about this, but we don't have a lot of time, and this subject itself is quite big to cover. So let's look at this particular implementation, what sort of time it takes. So, and just to give you some idea, we're not using some very high-end GPU. So just to let you know, this is a basic NVIDIA GTX 1650 Ti. This is based on the Turing architecture, and also like it doesn't have a lot of DRAM as well, just an 8 gig thing. And it's quite older GPU, but you can see the difference in this particular case. So let's compile this particular implementation. So matrix. This is utilizing the shared memory, and let's go shared. Yeah, so got compiled. Let's just run it. So shared CUDA. You can see it's even much more faster than the previous answer. Let's look at the time. So the time to compute this was shared CUDA. So this is also, this was 0.03. If you remember, the previous was 0.36 seconds. So this is utilizing shared memory. Now, what you can actually do is this, you saw basically from going from a CPU-based approach to GPU-based approach, your time actually got 10 times much more fast, a little more than 10 times actually. But you look at the difference between just a basic approach to moving to utilizing shared memory a bit. You can further optimize this by using by coalescing the memories. So let's look into this as well. So let's compile this. So matrix CUDA. And done, and just run it. It's to be honest, like by now you won't actually see the difference because the size itself is very small, but we can just modify this to increase the size. So let's look at the time it took to actually compute this. So this is 0.03 seconds, even more better, right? Now, let me just show you what happens if we increase the size. So let's add 2 zeros in both these areas. I'm sure this should be able to handle now. I'm only adding this because beyond a point, you won't be able to see what sort of optimization results we are going to see because this is 0.03. The earlier that you saw was 0.036. So not much, but let me scale the data size. So you'll be able to see the difference. So let's compile it again. So this is the basic implementation. So this is the basic CUDA implementation. Oh, cool. What's the error in this case? Support for offline teachers. Okay, let me reduce this. This is generally what happens when your device is not very configured to use CUDA. So I generally use a high performance compute machine Spartan that we have, but that's another case. I can't really use that for our operations over here. So let's compile it again. So yeah, so we've increased it by 10 times. And let's see the time difference to actually compute this. Now, the basic. And now you can see it's taking a bit of time because we've increased the matrix size by 10 times. So let me increase it on the other sides as well. And just for fair comparison. So it's going to take its own time. So see, it took around 16.8 seconds. Now, let's compile the other one. So MVCC matrix, CUDA shared. Yeah, so compiled, and this is, let's see the time for this. So we're using shared memory in this case, so this should be a little faster. See, it didn't take a lot of time. From 16 seconds, we've come down to 5 seconds. And I can guarantee you if you were to implement this in your CPU, this would result in overflow because it wouldn't be able to handle the amount of operations that we are doing over here. Now let's look into the furthermore optimized version, which is using coalesces memory. So just give me a minute. CUDA list. So CUDA, yeah. And let's look at the time for this. So you see the difference over here. 16, 5.4, 5.1, but if you look in the user section, you'll see 5 seconds per user, 2 seconds per user, and 1.8 seconds for the user. So that's the difference in this particular case. And since we're nearing to the end of our talk, although I have a lot more to cover in this case, but I'll be opening the forum for anyone to have any questions if they have. So anyone, if somebody is having questions, I'll be free to answer. And if you want, the following slides can be shared to you via the HRDC department.
We want, you can share it to us,
Sure.
and we will share it to the participants.
Cool.
Definitely share it. And one more thing is that if someone want to ask questions, please do ask, because Aditya is a good technocrat. He can answer your questions. Please answer questions. Ask questions. Anyone? No?
So this is regarding the coding, that is C or C++. I mean, is there any performance comparison between the Python and the C++? Because
Yeah.
since you
Okay, cool. So you can actually access CUDA via Python. So I'm sure if most people are doing machine learning, they'll be using Python, I'm sure, especially frameworks like PyTorch or TensorFlow, right? Now, if I just talk about PyTorch, PyTorch is actually heavily built upon CUDA. So it's a very optimized approach. So while if you're not doing a very heavy sort of research, your PyTorch optimized CUDA libraries would be fine. But why in this case I delved into C++ is, first of all, Python you should know it's not a compiled language, right? So anyways, from executing the code, it will first convert. So there's different forms of Python. The fastest one I know is C Python. So what happens is it converts it into a C code, and then this following C code runs. Now, this will naturally take a lot of time, because first you're converting into a C code, and then probably from C code you're executing into your machine level code. But in this particular case, C is much more faster, which I think it's almost as close as assembly. So one of the reasons why we're using CUDA over here is when you're going to use for very high amount of research where, let's say you're dealing with currently large language models are the buzzword, right? So if you're going to train a 600, 500 billion parameter model, and you're constrained by resources, you can actually see the amount of rush that is going on in companies building data centers. But you want to, as you increase the resources, the cost also increases. So you want if you're constricted by resources, you can actually delve into C-based CUDA implementation, and you can actually change the way it functions, much more customized to your particular own research. So I think that should answer your question why we're using C. And the only reason why I gave you example for C was this was the most high level CUDA-based programming that you will see. You can utilize Python, that's totally fine. I'm not saying there's any issue with Python, but it's just that it's very slow. I think.
yes, sir. Yes, sir. Thank you, sir. It answered me. Yes,
Yeah.
thank you.
Anyone else?
Good evening, sir.
Hi.
Sir, you were talking
First of all, please, to everybody, just don't refer to me as sir. You can call me Aditya. Yeah. Go ahead.
Right. You were talking about blocks and
Yep.
threads.
Yep.
Is it like a block like how do we interpret as a layman? Like block, thread is understood. It's a like task that's, it's been run in parallel. Like block is a kind of, is it like a local scope of a code? Like how could we interpret the term block in terms of?
So, okay, so you can just think of it like this. So combine multiples of thread together, you form a block. Combine multiples of block together, you form a grid. And that multiple of grid, combine it together, you form it into your GPU compute.
All right. So it directly proportional to somewhere the number of instructions we have per block. Like threads are directly proportional to
Yep.
number of instructions we
So
have in a program.
yeah. So basically, so if I were to give you a base comparison between CPU and GPU, your CPU might support 32 threads per
Right.
process, 40 at max, I
Right.
guess, right?
Correct.
With GPU can have thousands of threads.
Understood.
So that's the scale at which we're talking about.
Got it. Got your point. Right.
Yep.
Thank you so much.
Anyone else? By the way, also, if somebody is more interested into CUDA, I can suggest you a few resources. So NVIDIA has its own you can just visit Deep Learning Institute NVIDIA. And currently they have a lot of courses over there. You can review them. Apart from that, for NVIDIA is actually gearing up for the GTC conference. So you can take at least one course for free. So I would rather suggest just go for an intro to CUDA with C. That should be a very nice course if you want to delve into CUDA.
Aditya, and thank you, Manjeet, also for supporting. That was a great session, and I hope to have such sessions in the future also. These people are budding professionals. These are budding professionals, Manjeet and Aditya, and they are working under the guidance of Gagan Sharma, who himself is going to be a stalwart. He is, but he is going to become more bigger in coming in the days to come. So let us open, because these two people are very, very. So Manjeet, don't go. Aditya, don't go. I will request all of my friends to share webcam so that we have photographs with Manjeet and Aditya. Aditya had been speaking, but Manjeet was closely watching. So
yeah, Manjeet is the backend support over here.
Okay.
She's the star.
Hello, ma'am. Yes, ma'am.
That's good. Aditya, you did a very great session and it was quite informative. Thank you.
And just to everybody, apologies. It's a very deep topic to talk about in just 1.5 hours. So I did not have the actual idea about what sort of audience I'm having. So I tried to make it somewhat of an introductory course and somewhat into a little deep dive where we talked about the architectures. So maybe sometime in future, we can also talk about it in detail. Yeah, guys, if anyone else has any more questions, I'll be happy to answer. If you have even questions regarding where is the applicability of this particular thing, that's also quite fine to have a question like that. I think everybody is good to go.
So this is Prashant Lakkadwala from Indore, Madhya Pradesh.
Yes, sir, please.
I heard you joined too late regarding your session. I have heard only the last few minutes attended, but I just wanted to ask some question apart from this upon the GPU. What will be the feature of GPU and what type of data analytics and AI used for the GPU? Because our government is also interested for AI. This year they are declared for AI year. So the GPU purchasing or GPU work is very essential for the.
Okay, so two things. Depends on what sort of use case do you have. So I'm sorry, can you just repeat your question? A little missed out on what was
The main use of GPU in the future. The most of the application is now going to be a very huge, maybe a threading or maybe a data analytics or AI based data set what we have trained. So the GPU is essential for it nowadays. So how we
Yeah, so as I talked about, the main difference between a CPU and a GPU is uh, the advantage of using it for massive parallelization. You can parallelize in a very, very massive way. So when you talk about AI, it's a very broad topic to actually answer on, but let's say you're doing some sort of language model training there, or probably let's take an example for a computer vision based problem where you're dealing with images. Now, images are not just a bunch of matrices for computers, right? And as your image grows in resolution, size, color, channels, whatever it is, your the scale of the matrices increase. Now, if you're going to train something like, let's say you're training a segmentation model. Now, for that training itself, you're going to have like trillions of matrix operations that you're going to be performing. So in this case, you can't really depend on a CPU. So kind of as we move ahead, you're going to see a lot more GPU advancements coming up. But also one more thing that we need to be very careful about. As you build applications, your applications should also not be very resource or cost, like resource expensive or cost expensive. Just to take an example, the buzzword these days is DeepSeek. So they've done a very fantastic work in the way they're handling their inferencing for the model. So they've actually slashed their inferencing cost from 10 times, 15 times compared to the rest of the peers. So this is where, so somebody just asked me, what are some real applications of CUDA in scientific computing? I talked about one such application in, let's take computational field, computational fluid dynamics, CFD. If you're using there, or let's say talk about genomic data, which is quite huge. Now over there, you're going to have much like very high scale, high volume data that you would want to process. Now, the scale and the volume of data is such that even with today's best compute resources, they won't be enough. So you need to come up with certain innovative approaches in dealing with those particular operations. In this particular case, I showed you, you can do a basic matrix multiplication in CUDA. It reduces a lot of time. But what if that's not enough? So you can utilize shared memory. Furthermore, you can optimize it by using coalescing. So depends on what sort of application you have, but CUDA will definitely be there. There are other alternatives to CUDA, but since NVIDIA is the most dominant player in GPU market, we are talking about CUDA in this case. I think it should answer your question. Cool.
Good evening, sir.
Yeah, you can call me just Aditya. Please,
Yeah.
go ahead.
Sir, as there are the CUDA term is coined by specifically by NVIDIA, na? And what about some other companies that are also in the business of making GPUs like Intel,
Yeah, sure.
ASUS, Qualcomm, MSI, AMDs?
Yeah. So CUDA is specifically for, as I said, NVIDIA. So there are other general purpose GPU-based programming languages or platforms.
Is this term coined by NVIDIA only?
What term are you talking about? Can you be a little specific?
CUDA,
Okay,
terminology, the CUDA terminology.
It's not a terminology. Just to let you know, CUDA is a proprietary platform for NVIDIA. So if you want to deal with specifically NVIDIA-based GPUs, you're going to use something called as CUDA.
Okay, sir.
This might not be as effective if you're dealing with AMD-based GPUs, or there are other GPUs as well. So in that case, there are other similar general purpose GPU platforms out there. OpenCL is one.
Yes, sir.
So there's another platform called SYCL, which is somewhat a successor to OpenCL. It reduces a lot of its problems in SYCL. So you can look it up, actually.
And
this is a very, very big, great field to do research on.
As you have written two kinds of programs, first for general purpose C and second dedicated for the CUDA environments, and specifically designed for CUDA. And so far we have been running in our system as a general purpose C, and for the first time we have witnessed that there is a C programming for the CUDA environment that we run on the CUDA compilers, and the kind of compiler is written by NVIDIA or
Yes,
CUDA?
yes. So, okay. So there's the normal GCC compiler that you use for C,
Yes,
right?
sir, definitely.
Now, think of CUDA language as C with extensions. So extensions are to interface with the GPU.
Yeah, sir,
And
yeah.
because you're adding all of those extensions into C, you're going to have a new compiler, which NVIDIA calls it NVCC, which is NVIDIA compiler for CUDA.
Okay, sir. Thank you, sir.
Yep.
Thank you.
By the way, so if you actually are more interested, so we did we did see the matrix multiplication in CUDA, right? When you'll be dealing with PyTorch, and in PyTorch you're training some sort of model, over there in the backend itself, this sort of matrix multiplication happens, and those sort of implementations are very, very heavily optimized for you guys. So when you use Python and you, I'm sure all of us have used Python. So you use L.sort, right? Dot sort function. If you actually see, it's a very fast function, but nobody, so it's just not a function. There's a algorithm that is running behind it, which is which is called as lint sort. If I remember, Python 3.7 was lint sort. Similarly, when you use PyTorch and you have forward propagation, backward propagation happening, and the weights are changing for each layer. Between those each layers, you're basically doing matrix multiplication, right? But you don't realize that those algorithms that are working behind your basic functions,
Yes, sir.
they are very, very heavily optimized in CUDA, so that you can actually do all sort of training. But what happens is sometimes your data itself is so huge that even your current resources might not be very useful in dealing with it. Now, one thing is to buy more resources, but then when we are financially constrained, so you have to come up with innovative ways of dealing with those problems, which is where you get into C, probably change the way you're currently handling it.
Yes.
So that's why I introduced C with CUDA. I could have done it with Python, but it wouldn't have been any good use.
Yes. Yes.
Somebody says, which house? So which house? So basically asking what sort of LLM to use. I would say you can go with anyone at this stage. All the LLMs are like 9. So the basic difference between each of them is like 1920.
Hello, sir. Am I audible?
Yeah, please go ahead.
Sir, I want to know which GPU should be purchased to run the LLM model. Suppose I want to implement my own LLM model.
Okay, so that depends on what sort of what is the parameter size of the model?
Suppose parameters are middle range parameters. Suppose 10 million parameters के लिए if I want to make my own LLM model. So
for 10 million, so you can probably put the current GPU that I have with me is a very old GPU, 8GB RTX 1650 Ti. This
actually,
can handle actually 10,
has,
20, 50 million parameters. If you're talking in billions, then it will be a little issue. Go ahead.
because A100 GPU we were looking to have the setup in our college. So when we asked NVIDIA, so they said that nowadays the the production of the A100 is stopped, and you should go for H100 and H200, which is very costly. And alternate for A100, which is currently there in NVIDIA, is L40. So do you recommend, like, if the middle range parameters are there, and if I want to implement my own LLM model from the scratch, so shall we go for L40 GPU in that circumstances?
So as far as, I'm sorry, I remember L40 is a 48 gig GPU.
Yes.
And are you looking similar 48 gigs for A100? Because A100 comes with 48 and 80 gigabytes. Which
But
one are you?
A100, they are saying the production of the A100 is not available.
So probably you can also go look for a cloud-based solution. If you don't want to go for an on-prem, you can go for a
Okay.
cloud-based approach.
No,
You
no,
can
but
get
the problem is
bunch.
our institute is army based and we want the security mechanism. So we can't use the cloud services. The data is very secured. We
Okay,
don't
so
want to disclose that data. We want to implement this on our standalone machines.
there are ways to actually communicate data without actually compromising on security, but I won't delve into that right now. But yeah, if you want to go with the 48 gigs L40, I think that should be fine.
Okay. Okay, sir.
Thank you, Aditya. Lot of
Yeah.
questions asked and well answered. So a big round of applause to you. And thanks a lot. We will be meeting you once again for these kind of sessions.
Sure.
In the meantime, I
And
would say that it is the quiz time now, the final post-training quiz. So I'm posting the link on this chat only. Because of WhatsApp group, I've already told everyone that the link will be in this chat. There are 40 questions based on which are sent by our eminent resource people, and those 40 questions are there. Questions are easy, I think so. They have sent easy questions. So on the chat, I have already pasted the link. You can just see whether the quiz is opening or not, and tell me via this chat only. And please attempt the quiz. You have 1 hour. You have 1 hour. After 1 hour, we are going to close this. Actually, should have started, but I did not stop you from chatting with Aditya. Because
by the way, I should also mention Manpreet working behind the scenes from yesterday night. So thank you, Manpreet, as well for the support.
Manpreet is a hardworking professional now. So thank you, Manpreet. Thank you, Aditya. And let's hope you guys will rock like this in the future. Thanks a lot. All the best.